Okay, so what we have learned till now is like unsupervised learning. We are in unsupervised learning yet, we are not yet out. So and in unsupervised learning we learn the representation learning, where we have the PCA and the kernel PCA and everything. So in the PCA, what happened, like for example we have this kind of a graph, and we have the points here. So this is a line, we have the point here. Okay, so these are the points. I hope you can see it, correct? If you can't, then just immediately let me know. I will like just do the other things if you want it. But yeah, so these are the points. Okay, so what happened, we said that okay, these points looks like they are on the linear surface, they are having linear relationships. So we will draw the line and we say this is the best line in the PCA, and we said this is the baseline, and we were happy, and we said that okay, I will draw the proxy on the lines, I will draw the proxies on this line, and we'll get best we'll later on use the representation and coefficient, representative and coefficient, and we will compress the data by using like this relationship of the representative and coefficient. Okay, so here these are the points, and you are like happy, like okay, done, you say it's done. But the problem is the point is, no, week 3 only, we are in week 3 only. But how week 3 starts, that's like how this way we'll start it. Okay, so you are happy that okay, I'm able to do this kind of representation learning. I understood the data, draw the linear line and then plot the proxies here. Okay, proxies, and then I got the compression and all, like okay, as per the PCA. But this line which we saw it like here, this line has like most of the information about the data set, because your complete data set, which the green points which I have put it here, the green points are like plotted now, projected on this line, and now this line has a complete information. But is it like the complete information, or do we have another few more information that we need to see? So if you see the data set now, the data set is on the line, but the data set created some group. This is one group, this is another group, this is another group. Okay, so in this linear subspace, okay, or because if you see the two dimension, then it is a line. If you see this like a higher dimension, this is like a linear subspace. Okay, in this linear subspace, there is some kind of information about the data, like this kind of information what we are seeing now here. You are able to do the PCA, but in PCA, once you put the all the proxies on the line, like why these points are creating one group here, why this is one group here, why they are like in a group, why they are not spread it everywhere? No, they are somewhere, they are doing their projection on the line. But still, if you see, they are creating some clusters, they are creating some kind of a group in between them. So these points, whatever they are creating, these groups are these points what we said, these are the proxy points. And okay, and these points show these points are correlated here. Okay, okay, these points are, they like this point and this point, they are correlated. Okay, they show here, they are correlated, means there is something extra data available also in the data set that we need to figure out. Okay, that we need to figure out, we need to uncover this structure. Okay, we need to here, we need to uncover the structure in given data set. Okay, means why these points are creating group, why these points are creating the group, that we need to uncover. What is the what is the relation between that data set, that we need to find out. Okay, so that's why this is the theme of the clustering. That's how the clusters started. It's something like PCA we have done, we are happy with the line, but now we need to figure out why these points are creating the group on that line. Okay, why these points are having the kind of a clusters. Okay, for example, if I say you like take points x1, x2, x3 and so on. Okay, xn, these are your data set. Okay, for example, and all are like, you know that they are like a d dimension, like the height, width, height, weight, and your where you live, location, and all. Okay, these are d dimensions are like this. Okay, so these data set, and somebody asks you, can you create a group of the data set? Like you want to create a group of the data set. How you want to group them? Then somebody mentioned, okay, I will say k equal to 3, means I want 3 boxes, and you need to put all these data sets into the 3 boxes. But for time being, for 3 boxes, I will say x1, x2, x3, x4, and x5. Okay, 5 points are there just for these 3 boxes example. And I said you, okay, now I have 3 boxes, can you put the points into that box? You will say, okay, I can put. So what you do first, you will take x1, x2, x maybe x5 here, and here x3, and what you do here x4. This is one attempt you did. Okay, attempt one. Next attempt, what you do, you say, okay, I don't want to put x1 or something, so you will say x1, x4 here, and here x2, maybe here you will put x3, x5, and so on. Like you will try to do this kind of a arrangement of the box. So what happened, this box number 1, I will say here b1, box 1, box 2, and box 3. Okay, or you can say it's a box, because for example, for understanding you, or you can say cluster 1, cluster 2, cluster 3. Okay, it's a b1, b2, b3. So there is a chances this x1 will go to box 1 also, x1 may also go to box 2, and x1 may also go to box 3. Like this is like attempt 3, attempt 4, you will do like this, maybe x2 here, and then here x1, and here x3, x4, and x5. Or next attempt here x1. So you don't know, like you can put any, you can do, this is your choice, like you can put at any time any boxes. Okay, so here x1, x2, x3, x4. So this x1, x2 has a 3 chances. Okay, so this each box, each point x1, x2, x3, each point, what is here, yeah, it can spread, like it's your choice now. Yes, yes, means x1 can go into any of the 3 box at a time. Like in at the first attempt, I ask you, okay, Murli, can you put the 5 items? Maybe these are x1, x2, x3, x4 are the 5 items, and I ask you, can you put that items into the 3 boxes? You will go and put the x1 into this box 1. Next time someone come, Tejaswini come, she put the x1 in another box. Like when her choice when her time comes, so she put in x1 here in the box number 2. When third time Tejaswini come and she put in another box. Okay, so that is like each item, like each point here, x1 point has 3 choices. Either it will go in x1, either it will go in x2, or either it will go in x3. Okay, so x1 can go 3, like in 3 boxes, it has a 3 choices. Okay, x1 can go in box 1, box 2, or box 3. Same way x2 can also go 3 choices, x3 can also go 3 choices, x4 3 choices, and x5 also 3 choices. So what you can see here, if you see, so there are number of how many times you can position them, how many times you can position. I can put it here, here, here. So this is like a trial and error. You can put the combination x1, x2, x5 in one box, x3 in box, x4 in box, and another x1, x4. So you can create different kind of combinations and put them together. Okay, so there are some options also. Like if you can see there, what are the options, like you want to put all are there, like x1, x2, x3 here, and here x4 and x5. Okay, and the third box is empty. Okay, that's also okay. But if you see there, if you see the empty box also, and if you see how many times we can position this x1, x2, x3 into these, into this number of boxes or number of clusters, k equal to, here I mentioned 3. Okay, how many times I can position these 5 items. Okay, 5 means x1, x2, x3, x4, and x5. Total are like 5. Okay, how many times that 5 can go into 3 clusters? That is nothing but you need to use how many positions, how many times that you can position is nothing but you need to put 3 raised to 5 times. Okay, 3 clusters and this 5 times, 1, 2, 3, 4, 5. That is what 3 raised to 3 into 3 into 3 into 3 into 3. That is 3 raised to 5. Okay, So 3 raised to 5 times you can position these x1, x2, x3, x5 into 3 clusters or 3 boxes. Okay, so you will first point you will understand, okay, it is a 3 raised to 5, that's fine. Okay, that's fine. But whatever first time whatever you have done, whatever first time you distributed your items, and you are happy with that, or do you want to once again do the changes? Like you will say, okay, I have 5 items, I want to put the items as per their weight. Like one is very heavy, one is very lightweight, and you want to just put the boxes as per that weight. You are just putting them into the 3 boxes, the 5 items, and you found that, okay, I'm not happy with that, the box number 2 has maybe one is little heavy, I don't want to put that too heavy in the same box. Next time you will move the item from box 2 to box 3, and some lightweight you will put into x2. But how many times are you like happy with whatever changes you are doing? If you have any questions now, you can ask. Maybe I cannot see the our Google Meet, but you can ask me anytime. Okay, the question. So how many times you need to like put, that is like something like 3 raised to 5 times type, that is like a position, you can position them. And are you happy with that position, or are you still want to change that, or you want to reposition them? So that is something the problem. But what happened, like for example, so here we will come to that problem, but before that, this point you need to understand. Okay, this will come every time in the clustering. Okay, as I mentioned, there are x1, x2, x3, x4 and x5. Like for example, I took, okay, these are the 5 points I took, or maybe xn, like no need to point, okay, not to think more, x5 points. Okay, and each point, because as I mentioned, like x1, x2, x3, here box b1, b2, here what we mentioned, box b1, b2, b3, these are the box. Okay, these are the indicator, x1 is going into b1. Okay, and here this x1 will go into here b2. Okay, these are the indicator, x1 is going into b1, x3 is going into b2, x4 is going into b3. Okay, so these are the cluster indicator or the box indicator, b1, b2, b3 are the box indicator. Similarly, if you are having x1, x2 till xn data points, for them, and you have a chance of separating that data points and create a group of the data points and put it into some box. Okay, you are putting into box means what, you are indirectly creating a group or creating a cluster of that data points or input points into that box. Okay, so here I am saying x1 is the data point and I am putting into some of the box, and I am calling this one as a z1, and that z1 is what, here same way z2, okay, z3, z4, z5, and for xn zn. What is that z? Z is nothing but your cluster indicator. Okay, cluster indicator. What is z? Okay, z is your cluster indicator. For example, if I say you x1 example, okay, z is your cluster indicator. Okay, if I say you x1, x2, x3 and x4 and x5. Okay, for this z1, because z1 x1 is z1. Okay, these are the cluster indicator. Okay, so if somebody say z3 means what, x3 point, whatever the x3 point you are having, the x3 point is going in which kind of a box, box 1, box 2 or box 3, that z1 will say. Okay, or that z3 will say, for x3 z3 will say, z3 will have different values. Okay, that we will now understand. For example, your x1 is going into box number 1, your x2, okay, is going into box number 2, your x3 is going into box number 1. Okay, here it is different. Okay, your z3 means your x3 where it is going, either box number 1 or 2, like. Okay, and x4 for example, here x4 is going into box number 1, and x5 means your z5 is going, showing that x5 is going into box number 2. Means here how many boxes are there? We are having 2 boxes, either box 1, okay, or box 2. Okay, so what I am saying now here, I am saying in this box 1, okay, 1 second, yeah, In this I will draw this box 1 and box 2. Okay, so what I am doing here, I am saying x1 is saying like x1 is the point and z1 is the cluster indicator here. And what z1 is saying, z1 is saying I am having value 1, means x1 is going into the cluster 1, so or box 1. Okay, x2 means z2, for the data point x2 the cluster indicator for this x2 is z2. Z2 is showing equal to 2, means x2 is going into box number 2 here. Okay, x2. x3, what is saying, it has a cluster indicator, x3 has cluster indicator equal to 1. It is saying I am going into box number 1 because z3 is 1, so here x3 same box. Okay, x4, it is saying I am also going to box number 1, you can see z4 is equal to 1, so I am giving x4 also here. Okay, x4. Okay, and x5, x5 is saying I am going into, x5 is the data point and z5 is the cluster indicator for that x5, which is saying that I am going into box number 2 here, x5. Okay, so if we are having two clusters like two boxes b1 and b2, then and you want to put the x1, x2, x3, x4 and x5 these data points into the box, for saying that, because you, if when you get the data you will have some kind of a data with the cluster indicators here saying this is your output. Okay, it's like when you get the output you will have something like a z1, z2, z3, that is output of your maybe your clustering. Okay, but we are now having for understanding this x1 and z1 I am giving this example. x1 is a point which has a z1 indicator saying 1, so this z1 will go in box 1, z2 in box 2, z3 in box 1, z4 is also in box 1 because z4 is 1, that's why it is going in box 1, z5 is also in the box 2. Okay, so this is the way how you can say then that, how you can say, for example, if you are having x10 equal to z10, means you are telling my 10th data point has a cluster indicator 10, and if you are having k equal to 2, you are having just two clusters, two boxes, where your x10 will go, your x10 will go, that will showed by your z, that is your cluster indicator. z10 will show that, that will be maybe 1, means example. Okay, this is the example. So it say that my data point x10 having cluster indicator z10, okay, which has a value of 1, means this will go into this box 1 or cluster 1. Okay, this cluster 1. Okay, so if you understand these representation like x1, z1 and all, then it will be easy. But you will say how many times, because z is like now k is equal to 2, if z is equal to k equal to 3, what will do? So this, that's why your z whatever may be z1, z2, z5, I am having 100 data points x1 till x100, that's why I also have z1 till z100. Okay, cluster indicator, and what they will have, z1, z2, z3, z4, z98, z99 and z100, what they will have, they will have, because if you mention I just want to put the points into two clusters, that's all, I want to put the points into two boxes which is given by k value. Okay, so what z1 will have, z1 will have either 1, z2 will have either 2, z3 will have 1, z4 will have 2, z98 will have 1, z99 will have 1, z100 will have 2. This is the example. Okay, so though they are having like z1 till z100, you are having only the value of 1 or 2 only. Okay, because k is equal to 2 here, we have only two clusters. It's asked us to put the data points into two clusters only. Okay, that's why when z1 and z2 or till zn you are having the cluster indicator, that will go till, because that values will go from 1 to k value only. If you are having 2, then it will go till 1 and 2 only, that will just represent 1 and 2. If you are having 10 blocks or 10 clusters, it will go to 1 2 3 4 5 6 7 8 9 10. Okay, so z will go till 1 to k only. Okay, So this is something mentioning like which cluster is like this x1 point, which cluster it will go. So if I say z1 is equal to 5, so then it will go to 5 number of cluster, or the cluster number 5. Okay, so this is 1 2 3 4, 1 2 3 and 4. So this will go into box number 5, because here they mention x1 will go into 5. Okay, so x1 will go here. So did you understand now here this important nomenclature or important representation here, x1 and z1 point? Because z1 will come in now our when we solve some kind of things, then these points will come z1 z2, and so you need to understand what is this representing. Okay, you got this, Murli sir? Okay. Okay, here ma'am. Yeah, so yes, for I will tell you in another way, one example. Okay, I will say you another example, x1 x2 x3. Okay, x1 x2 x3. Okay, x4, maybe there is x100. Okay, so x1 x2 x3, for example, we'll take a example of a school. Okay, so x1 is like maybe our kid's name. Okay, maybe the one kid is my daughter name is Reva, so Reva and Ira. So x1 is Reva, x2 is Ira. Okay, they are having some name, they come to the school. So in school maybe there are different Reva and they Ira. So what school will do, they will give the roll number. They will say the roll number, what is that, roll number roll number 1, roll number here. Okay, z1 is roll number 1. Okay, so and here also roll number 2, z2, z3, z4. Okay, so you consider this as a z1, z1. Okay, z1 is their roll number. But what happen once the kid come to the school? Okay, they have some roll number. Now what you want to do, you want to just create you want to send them in their classrooms. Okay, classrooms, classroom. And you know that you are having a school from 1 to 5th standard, 1 to 5th standard only. Okay, standard school is there. So what they will do, or what will happen, there are maybe 100 students in the school. What you will do, or maybe 1000, because 100, there are 1000 students with 1000 roll number, z1 till z1000. What you say, okay, z1 will go in the classroom number 5, fifth class. Maybe the student is of belongs to the 5th class. So this is the class 5. Okay, so z1 will go here. What class 4, the student id z4, or the student id 4, he is also belongs to class 5. So student id z2 he is belongs to class number 4, z2. Okay, this is student id. Okay, and what happened, maybe student number x100 is having their roll number or id number is z100. So z100 will go into class number 3. Okay, here this z3 means roll number 100 is in class number 3. The teacher will say roll number 100 stand up, go to your class. So he will stand up and he will go to his class number 3. So class 3, class 4, and these things are there. Okay, maybe here x3 is belongs to class 5, x3 z3, the roll number z3 is belong to class 5. Okay, z2 is here, z2 is done, anything remaining. Okay, z4. This is just example. Okay, this class 5, class 4, class 3, and you know that your school is having only one class, 2 class, 3 class, 4 and 5. That's all. This is like till 5th only. The school is from 1st till 5th class only. They can't take the students for 6th class, because they don't have any they don't have permission. So the student has to go to another school for learning the 6th class onwards. Okay, so this is the cluster saying that k1, k2, k3, k4 and k5, this k value. Okay, this is your classrooms. Okay, and this class has a student id z1, z2, z3. These are the roll numbers or student id. Okay, roll number of the student. So roll number 100 is belongs to class number 3, that is cluster number 3. Roll number Z2 is belongs to class number 4. So you are having limited amount of classrooms. Though there are 1000 students, it's okay. That 1000 students are divided into the class 1, class 2, class 3, class 4 and class 5. Okay, that's why this is the cluster indicator. So here I am saying roll number Z1 will go to class 5. Okay, this is 5. And how much it will go? It will just, because this value, this Z value will represent, or this value belongs to 1 to K value. How much is the K? K is here 5. K is equal to 5. That's why we are having clusters from 1 to 5. Okay, so your Z indicator is belongs to 1 to 5. Okay, so is it answered your question, or do you have something different question? Okay, okay, so this is the point. Okay, so you are saying this example is just for understanding you. Okay, Z1, Z2, Z3, Z4. Okay, and now we will come back to our major cluster challenge. Okay, so like this notation now you understand, and you are now saying I have divided this one. Now x1, x2, x3, x4 and x5. You are saying I put this one into z1, z2, z, these are the indicators, z4 and z5. And what are the values for this indicator? Maybe 1, here 2, here z3 is 4, 1. Okay, z4 is also 1 and z5 is also 2. And you said that, okay, you said that these kind of arrangement, whatever I have done is very good. Okay, this is like really great like groups what I have created. I just consider the some features like maybe height of a student, so I am just creating a group of three groups, and I'm just saying that this group I want students whose height is 120 centimeter to 130, only between that height it will go to group 1. Next student will go 110 to 120, the other will go from 100 to 110. Okay, 90 to 100, something like this. Okay, there are the three different groups, but you have created the groups. Are you happy with that? Are you really happy with that or not? Okay, so that is what we need to understand. Whatever the creation we have done, the group creation, that is good or not. Okay, so to find out whether it's good or not, so in our, if you draw this kind of a graph, what you will do, so to understand whether this, whatever the cluster group you have created, cluster assignments you have given, x1 will go to, or x1 has a z1 cluster assignment will go to 2, z2 is 4, whatever the assignments you have given, is that good or not? So we have, for that we have a function called f of z1 till zn, because you are having 1 to 1000 students. Okay, or any example you can take, x1 till x1000, you are having these many values. Okay, that's why n is equal to 1000. So this z1 till zn. Okay, you are having this function which gives you summation of I equal to 1 to n xi minus mu of zi. Okay, okay, so this is objective function. Okay, this is called as objective function. What you need to do, I will explain to you what is this exactly. Okay, so what it will do in clustering, generally what happen, you have one point. Now we are slowly going to the algorithm. You have bunch of points here, any points, like they are linearly placed. Okay, these are the points. Okay, this is one more cluster group of the points here. Okay, consider they are linearly represented as of now for ease to understand the clustering concept. What you do, you will take the mean of all the points. You will take the mean. Okay, you will get one value mu. For this one, you calculate the mean of the points. Mean, you get a value mu, maybe here mu1. Okay, For this you will take another mu2, because this cluster also having one mean mu2, this cluster also having another mean mu3. So what you are doing now, each point you are using, each point, whatever these dots are here, these are like x points, okay. These points you are having, and you are just subtracting the mean from that point, your mu3, okay. This point is subtracted from their mean, and this same point here, maybe here is, for example, this is x1, maybe here is x5, this point, for example, x5 minus here is mu1. This cluster has some points, maybe here x98 minus mu2, okay. You are just subtracting that mean, and you are trying to figure out, you are just subtracting the mean from that each point, okay. Each point you are subtracting the mean, and you are trying to figure out whether this mean, and whether this value, whatever value you are getting, give me the minimum value, okay. But I will explain this point, but you try to understand, when you are having, for example, you are now at inside your house, okay. So what you will do, you will see that in your house there are 5 members. You will say that your main person is for your mother or your father. You will say that, okay, you will go and you will ask your father some points, and he will say, yeah, you are my son or daughter or something, okay. So he is saying that this guy, he is asking his mu means his main person now, okay. He is asking, I am belongs to this family or not, or I am belongs to this mu1, or this, here is mu3 and here is mu1, he is another family, another house, okay. So he is asking this guy, I am belongs to you or should I go to mu1, this family. Then what they will do, x1 minus mu1 mu3, something like this, they will calculate the some value, and it's saying that, okay, the value is 2 here. And when you do x1 minus mu1, it gives value, maybe difference is equal to something 50, okay. So the difference between its mean and that data point is less here, okay. And the same point, if you try to compare with the mu1, if you try to go and ask with this guy mu1, and belongs to your house, then the mu1 will say, I can't answer, just do x1 minus mu1. Then he just do the calculation, you got a value 50. So that state that the distance of this point, x1 point, okay, that state that the distance of this x1 point from its mean here is less than the distance of this point from this mean, okay. So the distance of here, maybe here I'll take x1, okay, x1 or x11 is the point, for example, and its mean is mu1, okay. And the same point, there is another family or which has the mean mu2, it will take the distance of x1 minus x11 minus mu1, okay. As it is a distance, that's why it is square, okay. x11 minus mu1, it will take the distance here, and also it will check the distance of x1 minus x11 minus mu2, okay. So it will check the distance, whichever shows the minimum distance, that is the point belongs to that cluster, okay. That is the cluster belongs to that point, okay. That is the cluster. So it understood that mu1 is the cluster and mu2 is the mean of the cluster, and I am belongs to this cluster only. I should not just go and jump to mu2. I am happy with mu1 only, because the distance between this point and its mean is really small as compared to the distance between this point and the cluster, the mean of the other cluster. That's why x1 will always be with the mu3 in this example, okay. X1 will always be with the mu3, it won't jump, this x1 will always be with the mu3, it won't jump to this mu1. It will say, no, I don't want to go to mu1 because this distance is less than this distance, so I am happy with mu3, okay. So what you are doing here, whenever you do this kind of assignment, or whenever you put your points into different boxes, x1, x2, x3, x4, different boxes, what you are doing indirectly, you are trying to figure out this distance of your point, x point, with the mean of that cluster, Okay, so this is the cluster 1 2 3, or I will say here mu1 mu2 mu3. Okay, these are the cluster and their mean is mu1 mu2 mu3, and you are having one point here. Okay, this one point here, this is point x. So first point, when you get, for example, you have a like a big CSV file, you are having so much of data, you don't know how to divide them into different groups. So what you do, firstly you will have some random number or random value, you have to start the clustering. So you should start with some dummy value, or some value you have to initialize, first value. Okay, you will say, okay, I am in cluster number 3. You will say I am in cluster number 3, x3. You consider like this is the one cluster, and you found that, okay, here. And you, what you did at the first time, you did like x minus what is this, mu3, x minus mu3 you did. Okay, you calculated the length square, and you found that, okay, x minus mu3 is having, for example, uh, capital A as the length. Okay, that answer is A. And you also do x1 minus, you also do next point at the same time, you also do this x1 minus mu2, x minus mu2, you calculated length. Okay, length square, that's why the length square, and you got the value B. Okay, this center, and here is the center. Okay, so every time you check with this and with this, and now you check with this one and here mu1. Okay, here is mu1. Okay, and you got a value C here, x minus mu1 whole square. You got the distance between the x and this mean of this cluster is something C. Okay, so now you understood there are like a B and C distance. A is what? A is x and mu3. B is what? X and mu2 distance, and C is what? X and your mu1 distance. Okay, C is here. Whichever is the smallest one, that you will choose. So here if you see, the distance of this x and this C is less than the distance of x and this, the distance of x1, x and the mu1 is smaller as compared to mu2 and mu3. Means this distance is smaller, means your x belongs to the cluster C. Then you can add this cluster, you can add this x into this cluster. That's all. Okay, so like this way you have to add the clusters. But how this formula, whatever, now we understood this f of this function, this z1 z till zn, these are the cluster indicators. Okay, and you try to understood that whether the z1 z2 z3, whatever the initial assignment, you got the points and you put it into the different clusters. Whatever I have put the clusters, like whatever the points I put into the different cluster or different boxes, are they okay? Are they are happy with where they are now, or they are not happy? So how you will understand that? So that is one, that is called as a goodness. Okay, that is called as goodness of the partition. I will write here, goodness of partition. Means whatever the partition you have done, okay, that partition is okay, means every point is happy with that partition or not, xi minus mu zi. Okay, and you are calculating the square. So in our earlier example I mentioned you x1 x2 x3 x4 and x5. Okay, what they are doing here, as I mentioned, the x1 is having cluster indicator as z1 equal to 1, z2 equal to 2, z3 equal to 1, z4 equal to 1, and z5 equal to 2. For example, when we said k is equal to 2, means only two boxes we are having, 1 and 2 boxes. Okay, so you have to put the points. So in that one, what I am saying, this x1 having cluster indicator 1 means what? You are saying the distance of x1 from the mean of this cluster. Okay, so these two boxes or two clusters, and if I just calculated the mean of this box 1, its mean is mu1. What about this? Its mean is mu2. So what I am saying here, the point x1 is in cluster 1. Okay, this cluster 1. So what it is saying, the distance of x1 from from the mean of this box or from this box is the minimum as compared to, like if I say x1 is here, this distance is smaller than this distance. That's why it say that you are in cluster 1. Okay, so that say that here, for example, if I say here x1, okay, what is mu zi? Zi means what? Zi is saying I am in 1, so that is mu1 plus x2. X2 is in cluster 2. It's saying that I am here x2, because the distance of x2 and the mean of the cluster mu2 is smaller as compared to distance of x2 and the next box mu1 here, box number 1. It's like more as compared to here, so it will choose this mu2. So I will write x2 minus, what is that? Zi means what about z2? Z2 is what? 2, because it's a summation, that's why I'm adding all these things. Then what I will do, x3, okay, sorry, it should be square. X3, what is z3? Z3 is 1, that's why mu1 square plus x4 minus, okay, this is what? Z4 is mu1, Z4 is what? 1, so 1 square plus Z5 minus, here this is 2, so u2 square. You got these one values. Okay, okay, but what is the point now? What is the point now here? Okay, the point is, this is called as goodness of your partition, but the point is this formula, whatever goodness of partition. Okay, here the point is, yeah, yes, for this example, whatever now the example I gave you, x1, x2, x3, x4, I mentioned this z1 is 1, okay, z2 is 2, z3 is 1, z4 is 1. So what, how I have given you, saying that this x1 is near to that box b1. How you will find that box? See, box b1 is having so many points, you can't go and calculate the points. You can't go with this point and calculate the distance, this point and calculate distance, this point and calculate. So what we have there one representative. Who is the representative of box 1? That is the mean of that box. He is the representative of the box, he is the mean. Okay, so this is mu1 is the mean of the box 1. Now instead of calculating the distance of every point, like these points and here x, so what you do, you said that no, I want to calculate this whatever the point I am having. So instead of getting small other points, I will just go to the mean of that box, okay, and I will calculate the distance of that point. Okay, this one. And you found that there are two boxes here. Okay, box number 2 is here and it has like mu2, this is mu1. You found that the distance of this point from the distance of x and the mu1 is, for example, small a, and x and this mean of the another box 2 is b. So which is smaller one? A is smaller, correct, and b is here, so b is bigger than a. Means it's saying that the distance of your point from this mean or from this box is smaller. Means indirectly saying that you are belong to this class, you are not belongs to the box number 2 or not belongs to the cluster number 2, you are belongs to this class. So that are the, you are calculating indirectly the distance. Okay, the distance say you whether the point belongs to which cluster, cluster 1, cluster 2, cluster 3. Okay, so for doing that, what we did here, so that's why here these are the just example. Okay, this is just example I mentioned you. Z1 is 1, Z2 is 2, Z3 is 1, 4 and 2, because we want to only 2 clusters. For example, there are 3 clusters also, then it will be 1, 2 and 3 kind of thing. Okay, so here only 2 points and I just decided, I say that Z1 is 1. So here mu and Zi, it's mentioning Zi. Okay, what is Zi? Z1, Z2, Z3, Z4, Z5. Okay, and what is Z1? Z1 is 1, Z2 is 2, Z, hey, this is 1, this is 1, this is 1. Okay, that's why mu1, because mu will be mu as it is mu, Zi will be replaced by their whatever value, 1, 2, 1, 1, 2. That's why 1, 2, 1, 1, 2. Okay, So this is the way how you get the goodness of the partition. But okay, but the point is now here, okay, what happened, like you will say I did this kind of a partition. Okay, so you have to find out whether whatever the partition you have done at the first time, whatever the x1 till x5 you just put into different two boxes, are you happy with that partition or you are not happy? Okay, to say that I am happy or not happy, we have one point, we have one value that is called as a, we have one formula that is called as a goodness of partition. And that what the formula is saying, that formula is saying like this is a function of z1 till zn. Okay, and it is saying that summation of all I equal to 1 to your n, okay, xi minus mu zi, okay, it's a zi, remember it's a zi, okay, it's not k, it's a zi, and zi may be 1 2 3 4 5 6 7 8, like 1 2 1 1 1, that may be the value of k, but it is not like like it's not mu k, it is mu zi, because you will ask the question in the exam that what is the formula of goodness of the partition, and there is option of, there is option of mu k also. So this mu k is not the correct one. Okay, like 1 to n xi mu k, this is not correct, this is not the correct option. Okay, it's not correct, this is the correct, because it's not k, it's zi, it's a representation, it is giving you the value of k, but it is not actually, it is not actually, like you cannot simply take k, and you should not like simply put k equal to 1 to 2 and then mu k, it's like what, mu 1 mu 2 mu 3, but it's not like this, mu 3 mu 4 mu 5, it's not going like this. It is something saying that zi, what is the first xi belongs to which cluster, okay, that's saying by zi, z1 is saying that I am in cluster number 2, z2 is saying that I am in cluster number 3, z3 is saying I am in cluster number 1, like this. Okay, so that's why you, if you take here, the mu1 is saying mean of the cluster, so it will be something like for this example it will be something like mu2 here for this example, mu2, okay, and what is this, z2 is, so this is different. Okay, this is different, and what I am saying, this is different here. So this is by using mu zi, so it's a mu2 mu 3, and what is z3 is 1, so that's why here 1. Okay, and so on. Okay, so this formula is the correct one. Goodness of the partition, if you want to get, you have to do this one. But the point is, whatever now I did this one, x1, I did this x1 minus mu1 whole square, x2 minus mu3 whole square, x3 x4 minus mu1 whole square, whatever I have done, is it okay, or it is something like not, you are not happy? So to understand that, so our actual goal is now what, our actual goal is whatever value you have calculated, whatever value we have just now calculated, is xi minus mu zi whole square, whatever value you have calculated, that value has to be minimum. Okay, minimum over all the points, and that should go from your z1 till zn. Okay, so now the values which I got, the value which I got here, x1 minus mu1 square, I just write here x1 minus mu1 square, x2 minus mu2 square, x3 minus mu1 square, x4 minus mu4 square, and x5 minus mu2 square. This value you are happy, or you want to go for the next one? So whatever now you will get a value, maybe you get you got a value called as you got a value called as 1. Okay, maybe not 1, maybe 10. The result of this equation is 10, for example. Okay, next time you are saying that, okay, let me also check whether x1 minus mu2 square, okay, x2 minus mu2 square, as it is here, you are not, you, what is saying that x1 minus mu1 means here x1, and here is your mu1 and your mu2 is here. Okay, it's saying that this and this distance. So at the initially you were saying that x1 and mu1 has a sufficient distance u1. This distance is like less than the b, means you said that x1 belongs to this cluster, but later on you found that no, this is little more, so I want to also check with this distance x1 minus mu2, so here I am taking mu2. Okay, maybe then x3 is also having same issue, x3 minus mu2 whole square, x4 minus here not mu4, it is something mu1 here. Okay, x1 minus mu1 whole square, this is just example. Okay, x5 minus mu1 whole square. Okay, so with this attempt, with when you do this, you got a value equal to 8. Okay, for example, you got a value equal to 8. So you need to check now, you need to check, your goal is what? Your goal is to get the minimum value. So here with this first attempt, when I did that, I am saying x1 is near to mu1, x2 is near to mu2, x3 is near to mu1, x4 is near to mu1, x5 is mu2. This type of distribution, or this type of whatever, like you got the opportunity to separate these x1 till x5 into two boxes, and you put x1 to mu1, and you got a value, total value equal to 10, and you said no, x1 belongs to mu2, just check with that, and you got a value 8. So you understood that the value 8 is the minimum as compared to the value 10, means this kind of distribution is the correct distribution as compared to the 10, this distribution. Okay, so whatever the distribution you have done in this step, this stage 8 value, this distribution is good as compared to 10, so you will go with this final distribution. This is your final distribution, you will go with this distribution now, because your goal is to get the minimum of xi minus mu zi whole square. This is your goal. Okay, this is your goal, this is the goal of your, like not the clustering algorithm, you can say. This is the goal of your clusters, like when you are creating the clusters, so clusters should give this value, and this value should be the minimum with all the options you have tried. You tried with the option of x1 minus mu1, and this first option you got a value 10, and you then modified x1 and mu2, you went to mu2 and just calculated same way the distance of x1 till mu2, and then do the summation, and you found the value 8. And in that one, whichever is the minimum, 8 is the minimum, so it's saying that x1 is more closer to mu2 rather than mu1. It's saying that x1 is more close to mu2, means your cluster 2, rather than close to mu1. That's why you are now moving to this distribution, saying that this x1 belongs to here, this mu2, so they are in the same cluster. This x1 belongs to the mu2 cluster. You just want whatever this is the objective function, this is the objective function of your k-means cluster. Okay, so objective functions state that I will do all the summations like x1 minus mu1, x2 minus everything I will do, and I want the value, I want the arrangement of the z1 to zn, which give me the minimum value of this equation, this formula. The whenever I do the summation of xi minus mu zi whole square, whenever I do this one, though the values of z, like the z1 and z2, what it say, it say that your cluster indicator. So value of the cluster indicator, which gives me the minimum value of the complete x summation of xi minus mu zi square, that is the actual combination I am interested in. That is the combination. Like first attempt I put x1 to mu1, that is not correct. Maybe after this addition once you do the summation, you got value 8, and this says that this x1 has to go to mu2, it should not go to mu1. This is wrong, because the equation that gives you value equal to 8 means the minimum value whichever gives the combination of z1 to zn, the minimum value which combination gives, that is the best combination which you need to choose, and that gives you the actual clustering, that gives the actual clustering part. uh, yeah ma'am, yeah, tell me. X1 could be the mu1, correct, you mentioned like this. That's good, na? That's good because we are doing addition, na? So means in this complete cluster you are having these points. Okay, okay, these points. Now what you did, you just calculated the mean of that. So mean, whatever mean of these cluster points means, you also got one point which is the mean of the cluster, and maybe there is another point who is also here. That's okay. But what it's saying that the distance of your x1 till mu1 should be less. If it is 0, that you are like, you are most happy person, that you, whatever the first attempt you did, that in the first attempt you send this your x point into this cluster. Okay, you send this point to this cluster, and that is perfect, fine. You no need to now later on jump this point to another cluster because you are in the correct cluster group. Okay, so that is, if the value is 0, that is a perfectly fine, that is like a best condition, that is like a best condition in the clustering. For if I say this point and there is another cluster here, because the point has to check every time with all the mean. Okay, mu1, mu2 and mu3 also, and this point has to check its distance between this point as well as on this point as well as on this point. If the distance is 0, now it never jump. Now it will say I am happy, I am converged. This is called as convergence. It will say that I am happy, I got my actual group, I am not going to change my group because the distance of x and this mu1 is 0, so I will be every time will be this group. But some people are like, they are not, or the some points are not happy, they are saying, oh unfortunately I unfortunately this is maybe point number 3, he is saying unfortunately I got added to mu2 because the distance is here, and when I calculated the distance between x3 and mu3 is maybe b, and this distance is, or maybe I can write the value as a 4 here, where distance is 4, the distance between mu3 and x3 is 4, and this distance between mu2 and x3 is maybe 8, or not 8 but 6. Okay, not big difference. So I understood that I am not belong, x3 is saying I am not belong to mu2, I am belong to mu3. So in next iteration it will change its group, it will change the cluster, and it will just go and jump into this group. So earlier your groups were like this. Okay, maybe this x3 point, but next iteration if you see, the groups will be something, this x3 will come here. Okay, this is your first iteration in the for loop. They will check every time, we need to see whether we are converged or not. So that will come to know on next point. But in first iteration you will say that okay, this point belongs to cluster number 2. Okay, but you understood that the distance between this mean and this is like, this example is not the correct way I am showing the representation, but you are saying that the point is not belongs to mu2, it understood because of the distance of your mean. For this point is okay, and this may be here, this is new point. If I just want to draw new point, I am saying this is like here, the distance of this mean and this point is maybe 6, and you figure out okay, the distance of this between these two will be 4. So I am not belongs to cluster number 2, I am belongs to cluster number 3. So in the next round what happened, the same point will come now here in this cluster, and they will create another group, like this group is added, and the cluster 2 is shrink now because it earlier just had this point, and now cluster 3 is enlarged and take this point, and the cluster 2 is shrink and it got reduced. Okay, so every time you have to check the distance of your, like your data point and its mean, and otherwise its mean also and its neighboring mean. That is the way how the clustering has to do every iterations. But how many iterations you will do, that you have to understand. But before that, this whatever the goodness point, this goodness formula, you understood this goodness formula, xi minus mu zi whole square, that is the distance, you are calculating the distance and you are adding the distance of every point. Okay, whatever the cluster mu is having, for x2 is cluster mu2, x3 cluster mu1, x4 cluster mu1, x5 cluster mu2, whatever the clusters you are having, you are just getting the distance of that same point with the cluster mean here, and you are calculating the distance here 10 and 8. But if you actually see what is mu, Mu is what? It's a mean. We are saying it's a mean. That's fine. But how to get the mu? Mu value has to have some mathematical explanation. Correct? This mathematical explanation that I will now give you. So it's a z1 to zn is summation I equal to 1 to n. This is what your actual goal of your clustering zi. Okay, always remember it's a zi whole square because you are calculating distance. That's why whole square. It's L2 norm. Okay, z mu zi whole square. And here mu zi is the average or mean of zi clusters. Okay, like whatever the clusters you are now having. So that will now understand that in formula I will just show you, and then I will give you what is this exactly. Okay, this is nothing but your mu z is nothing but, okay, this, just remember this formula. I will just in next point moment I will explain you. Xi into indicator function, this is one is indicator function, zi of k whole divided by is indicator function, okay, divided by summation of I equal to 1 to n zi equal to k. So what is this? How we can how we can get that? But before that, what is this indicator function? Means what? Indicator functions mu of u, this is value u, okay, is either 1 or 0 if mu is true, okay, if mu is true, otherwise it's a 0. That you will understand with this, okay, with small example. So what it is saying in your this example of x1, x2, x3, x4, x5 having zi value, okay, z1 is what? 1, 2, 1, this is a 1 for example, and this is 2, okay, and because k is equal to 2. So what mu, if someone asks you can you calculate mu here, like mean of that, so I will say that okay, because there are two boxes b1, or like I mentioned there are two clusters or two boxes 1 and 2, and I want to calculate the mean of the first box mu1. Okay, mu1 is what? Okay, mu1 is see here, so this should be k, because we have to calculate how many clusters, k equal to 2. So you want mu1 and mu2, like this you want to calculate. Okay, so mu1 is what? As per this formula, xi into indicator function where zi equal to k. Okay, so here, okay, so first this zi is the, for example, is a 1, okay, it's a 1, z1 is what? 1, z2 is 2, z3 is 1. Okay, so what it is saying that, so mu1 is what? Your k should be 1 here. So I want to get cluster 1, k should be 1. So when zi equal to 1, this case, so whenever zi equal to 1, what are these zi equal to 1? Is x1, the 1, x2, oh sorry, not x2, here x3, because this one value, x4 one value, so x1 plus x3 plus x4, okay, summation of divided by summation of indicator function, how many times they are coming? 1 time, 2 time, 3 time, divided by 3. Okay, means zi equal to 1, how many times zi equal to 1 is there? 1 time, 2 time, 3 time, that's why 3. Okay, this is 1. What is the mean of your cluster number 2? Mean of same way xi into the indicator function, when you want zi equal to 2, zi equal to 2 is what? Here zi equal to 2 is this case x2 and this 5 x5, how many times they are coming? 2 times. Okay, so this way you can calculate the mean of your This way you can calculate the mean of your cluster. Okay, so calculating the mean is something this formula, xi into indicator function. What is this indicator? It is saying that whenever zi equal to k means what? You are having k equal to 1 or 2, because we are only having two clusters, k equal to 2. That's why you are having 1 or 2. So when zi equal to k, that time, sorry, zi equal to 1, because you want to calculate mean of one cluster and mean of two cluster. So when zi equal to 1, how many times 1 is there? X1 time here, x1 is having 1, and x3 also having 1, x4 is also having 1. That's why x1, x3 and x4, how many times they come? 3 times. That's why 3. Okay, same way for mu2, x2 and x5, because they are having indicator cluster indicator as a 2. So x2 plus x5 divided by 2. So this way you can get the mean of the cluster 2, mu2 and mu1, this way. Okay, any question in this? Murli sir? Okay. Ashwini ma'am, anything, any question here? Okay, super. So this is the point, which is something like a 2.3.1. Okay, so you need to understand what is this formula for this. So someone asks, like, you have to calculate mean of the given cluster 1, mu1 or mu2. Okay, so this is k. Just let me, okay, this is mu k. Okay, k. Someone asked that, okay, can you calculate the mean of first cluster, which is saying that whatever the points you are having, you just check the points and their cluster indicator. So if that cluster indicator is saying like if 1 1 1, okay, they are going into the one group, x1 plus x3 plus x4 here divided by 3, like how many times they are coming? 3 times. The same way x2 plus x5 divided by 2. But what is the point now here? So what I mentioned now here, so our goal is like what just I mentioned you. The main goal is, I'll write down, the our main goal of clustering is, you need a minimum value over all your data points from z1 till zn. You need to get minimum of what is the minimum value you want? You want the minimum value of your distance calculation, xi minus mu k, no mu k, it's a mu zi whole square. You need the minimum value of this one. But do you think it's a easy one? Is it easy? Like we have maybe 2 points, like we have maybe 10 points, or like for example 5 points. You divided the 5 points into 3 clusters. So how many possibilities we have? Like we saw that x1, x2, x3, x4 and x5, 3 possibilities, these 3 for this, 3 for this, 3 for this, because you can put into box 1, 2 or 3. Okay, so 3 possibilities means what? 3 raised to 5. That's fine. Okay, that's you can easily calculate it. But it's an easy point now. If I am having x here and k is equal to 3, okay, that is what? K raised to n. Oh, sorry, that is n, number of points. Okay, n, k raised to n. Okay, so for example, I am having number of points is equal to 1000. Okay, and I am having only 2 clusters. So what it will be? It is something like now 2 raised to 1000. So these many possibilities are there that you can put your points, like 1 point add this point into the k means what? 2, which is like you are having 2 boxes, 1 box and 2 box, but there are 1000 of points. You either put here or you put here. Later on what you do? You put here with the combination of these two. You will go here and later on you will say that okay, it's not good, then you will change the combinations and you will go to with another new combinations, you will go to here, then one more combination you will do, you will get this point, and maybe next point you will create another combination and go here. So this way you create a combinations. And also there is a empty boxes. If I just consider like empty boxes, if I want to put everything here and nothing is here, or some combination here and no combinations here. So if I do this kind of way, so there are total combinations will be k raised to n, which is nothing but 2 raised to your 10,000. That's very huge amount. It's not infinite, but it's a finite only, but very huge amount. So that's why if you want to choose what is the best combinations, I can put this point x1 till x5, what are the best combinations I can put and put into these different boxes. This is not an easy problem. This is called as NP hard problem. Okay, NP hard problem. That in our machine learning field you will every time hear this word. Okay, NP hard problem. What is that? This is called as something non-deterministic polynomial time hard problem. Okay, so whenever somebody say this is the NP hard problem, it is possible, like yeah, it's okay, like maybe 2 raised to 1 is what 2, 2 raised to a 3 is what 8, 2 raised to 10 is what 1024. Okay, these are the values. But 2 raised to 1000, there may be some value, you can get it, but it's really complicated. Like it's not easy to get the values if you are having pen and paper. It's not easy to calculate out. If you want to just distribute your 1000 point into two boxes, you have to do all the combinations, like this combine x1 with x100 and then put into box 1. These are like you need to try all the combinations. How many combinations you will try, or how many ways, how many positions you will try. That's like 2 raised k raised to n. Okay, k means cluster raised to that many points you need to try. And that's problem is called as NP hard problem. And if like for just for your understanding, I'm saying that for what is NP hard problem is, for example, p is like, consider one problem. P is like a one problem, like you want to calculate the maximum of two number. Which one, ma'am? Okay, so k power n is what? For example, I gave you the example of x1, x2, x3, three examples. Okay, and maybe the same example I will take, means you will understand when you go through the video once again here. Okay, so what happened now, we are having this point x1, x2, x3, x4, x5, and your task is to put these 3 points into put these 5 points into the 3 boxes. That's box number 1, box number 2, box number 3, with any combinations you can put. Okay, any combinations. What you do first time, you will say that x1 and x2 will go to box number 1, x3 will go to box number 2, and x4, x5 will go to box number 5. This is one way. Out of that, for here what happened now is k is equal to what? K is equal to 3, and n is equal to what? In this case, n is equal to 5. So how much is the value 3 raised to 5? How much is the value of 3 raised to 5? Do you know anything? We need to maybe calculate that. Okay, so let me see that 3 raised to 5. Calci. Okay, so 3 into 3 into, that is something 243. So here whatever now x1, x2, x3, x1, x4, x5 I did, it is one value out of 243 way. Okay, next time what I will do, x1 alone, x2, x3, and here maybe x2, x4 here, and x3 and x5 here. That is 2. That is that is 2 second way of out of 243. And if I do one more time x1, x2, x3, x4 and x5, that is one more way. So like how many ways you can try? You can try 243 ways to just separate out these values. Okay, to put these values here, 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 like these boxes. Okay, how many ways are here? This is 3 raised to 5 ways, 3 clusters and 5 the total finds. So that is coming as 243. So 243 ways you can put that 5 point into 3 boxes. Okay, so the one way is like this: x1 x2 group, x3 and x4 x5. Second way is what? This one: x1 x2 x3 x3 x5. And here third way is what? x2 x3 x1 x2 x3 d power yeah, in our PCA you understood that d power p, correct. Okay, but here in this one, instead of because d is the number of clusters you are having. Okay, for here you can say that d is the number of clusters. Okay, and p is number of your points you are having. So it is d power p, something like here k is your number of clusters. So the nomenclature wise, the instead of d and d raised to p, you don't need to, like, you don't should not mix these two formula in the same way. Like, you can understand in your way, you can use some tricks, but it is something. K means what here? Cluster, and raised to how many points you are having, k raised to n. Okay, so that many times, like that many ways you can arrange this point. I arrange x1 x2 x3 together, x5 together, x4 and x5. Means, for example, these are your like these are your having some kind of like, okay, there are 5 kids are there, and you want to make them like create a group for playing some games and all. So you created group of x1 x2, the 2 kids, the kid name is x1 and x2. You created one group, and here one group and here one group. In this group he is alone. Next time you understood that, okay, I don't want to do like this, then you created next x1 is like this, the kid is alone in this group, this x2 x4 x3 x5, second way. So how many times you can do that? You can do 243 times. You can rearrange them this way. Okay, and this also includes some groups will be having zero value also. Okay, like you will have all x1 x2 x3 x4 and x5, all values in the same group, but no value here. So these combinations are also included into k raised to n. Okay, these combinations are also included into k raised to n. Means you are totally, I'm not saying this is just with the now without non-zero values. This is like total combinations. Okay, one box having empty also, the cluster which doesn't have any value, that type of combination also. So total your combinations will be k raised to n. These many combinations you can do. So this is something like a 3 raised to 5, I took the example. But for example, you are having k equal to 2 clusters only, and you need to put this 1000 values, 1000 points. Okay, 1000 points. Okay, 1000 kids, and you are having only 2 classes. Okay, and now you need to do combination law, like x1 x2 will go into class number 1, or x1 x3 will go to class number 3, class number 2, or x1 x5 will go to class number 1. Like you need to make a combinations of that, like how we did x1 x2 x3 x4 and like this. Okay, so here what happened, now we are having 2 classes only and 10,000 kids, 1000 kids, like x1 till x1000. So you need to check the combinations. How many combinations? In earlier case we got 243 combinations, but now how many? 2 raised to 1, 2 raised to 1000. These many combinations are available, and you don't know in one combinations. Here we saw that in this one combination, here the 10 value what I showed you here. In this one combination you got value, some value 10. In next combination you got value 8. In next combination you may get value 6. In next combination you may get value 12. So how many times I need to do, if I am having 1000 points, how many times I need to create a combination? 1 2 3, how many times? 2 raised to 1000 times I need to create that combinations. And I need to figure out which combination having minimum value, that is the combination which I need to choose as a like a cluster. That is the best clustering point. I thought, okay, now whatever the final cluster I have created, this cluster 1, sorry, this is the 1 2 and 3. So whatever now points I have, I just divided the points and put it into the proper groups. And now whatever these groups I have created, these are the final groups. But how many times you have to do that? You have to do if there are like two clusters with 1000 points, you have to do this many combinations, you have to use this many combinations, and to figure out which is the best one. How you figure out? You just calculated the summation of xi minus mu zi, you calculate the distance of that, and you are interested in the minimum value of that, minimum value of this from z1 to zn. You want minimum value of this xi minus mu zi whole square, the addition of everything. You want the minimum value of that, like how we got 10 and 6 and all. So that minimum value is the best combination, like here I shown 10 value or here 8 value. So 8 is the minimum, so that's why out of these two I choose 8. But if it is 2 raised to 10 1000, it's like a huge, you cannot easily calculate. That is called as a NP hard problem. That is called as NP hard problem. Okay, when someone like ask you what is NP hard problem, because you every time use the word NP hard, NP hard. What is NP hard? NP hard problem is what I mentioned. It's like a non-deterministic polynomial time hard problem. This the definition of NP hard problem. And I was giving one example of what is NP hard means. Like it is not given in the week, but I am just giving so to know you, like when you just need to simply say NP hard. If someone asks you what is NP hard in the interviews, you are saying NP hard, what is that? You should have some kind of analogy to explain that. So here P means, just example, you consider P means you want to figure out the maximum or maximum number in the given list. That is easy, you will do that. Or you want to figure out maybe sort the values, or ascending or descending order. That is like normal P problem. Okay, normal problem you consider. Okay, NP means what? NP means what? NP means you are having some Sudoku. Okay, some Sudoku you are having, or some puzzle that you need to solve the puzzle. Okay, in the newspaper and all you get it. Okay, but provided that they are also given the solution of that puzzle. They say that okay, this is the solution of the puzzle. Okay, and then you will see that oh, this is solution, and you understood the solution, and you will check whether the solution is correct or not, because you have already the solution. You figure out and you are cross checking the solution is correct or not for this Sudoku. Okay, that is called as NP problem. What is NP hard? NP hard is the problem which is the hardest problem in that Sudoku. Okay, which is the hardest problem in that Sudoku, that you can't easily solve it. Okay, that you can't easily solve. NP hard. So you saw that P, NP and NP hard. NP hard is the same problem from the NP, but it is having like really difficult solution. Okay, you don't have any kind of reference output or something to check, because in NP you are having some reference output of Sudoku and its output. So solved Sudoku, and then you are cross checking, oh he's correct now, oh he did correct, because you are already having the solution and you are cross checking it. But in NP hard, it is the hardest Sudoku you have to solve by yourself. That's why they call it as a NP hard. But you can solve it. Okay, you can solve it. If you solve the NP hard, then you can easily solve, like if your brain is easily solving this kind of NP hard issues, NP hard problem, then you can easily solve the NP kind of problems or P kind of problems, and that will be like easy for you. Means some kid is solving standard 8 paper which is P, and some kid is solving solving IIT's old paper, IIT JEE exam and all. That is something like NP, because old paper also having solution and you are like cross checking, oh it's fantastic. And some people is solving the MIT levels of paper and all, like maybe IIT's this year paper in the exam, because he doesn't have any solution. So and he is able to solve, if the kid is able to solve the NP that kind of paper, means he is solving NP hard problem, then for him NP and P problem will be easy. So that NP hard is the toughest problem of the IITs. Whatever paper you solve, that is because you have solution, so it's NP problem. But now this is unknown paper, you don't have any solution, you have to solve now yourself. That is called as NP hard. So the how it is coming to, how it is related to our thing here, you know that they are like x1 till x5, and you are having three clusters. That's you are easy to solve with 243, like k raised to n possible ways. K raised to n, these are the possible ways for solving. So three clusters and 5 points. Okay, three clusters and 5 points. That's easy. K raised to n, like not easy, but that is the NP problem, for example. So you can do this kind of a combination. You take a full day, or you are having big CPU with the GPUs and all, so you can create a threads and solve it in some minutes, that problem, if you are having resources. If you don't have, you can sit in whole day and try to create a arrangement of x1 till x5, and you will figure out which is the best clusters for these 5 points, how I can put these points into different clusters. Like this, you can create their groups, which is the best group you need to figure out. But if it is like a 2 points and 10,000 1,000 two clusters and 1,000 means it's not infinite points, but it takes a time. So that is called as NP hard problem. Okay, so this is something, the NP hard problems. So to solve this we are now coming to the solution of this problem, which is NP hard problem. Okay, the solution to solve these kind of issues, we have developed an algorithm called as a LLYODS algorithm. Okay, to solve this kind of NP hard problem, like to figure out which is the best group of the points, which gives me the which gives you the minimum value of xi minus mu zi whole square. Okay, I equal to 1 to n, and you are interested into that minimum value of these points. Okay, minimum value of this equation. And how many equations you are having? 2 raised to, if it's the two clusters with 1000 point, this many combinations are there, and you have to figure out which is the minimum one. That is the NP hard problem. But that to solve this NP hard problem, we have algorithm called as a LLYODS algorithm, or it is also called as a k-means algorithm. Actually this problem is called as k-means problem. So and we say, that's why we, instead of saying k-means problem, we are saying k-means algorithm or LLYODS algorithm. Okay, week 2.2. Okay, so this is the LLYODS algorithm, which will help you to solve the issues of your figuring out which is the best possible way you can put the points into these clusters. Okay, x1 should go to x1, or with what combination should I put x1 into this x1 and x2 together here, or should I put x1 and x5 together? So you have to decide, and you have to figure out which is the best combination. So to solve that, you have this LLYODS algorithm. Okay, before starting this, any questions? Any questions? No. Okay, yeah, now we are, oh, sorry, 3.2, I'm sorry for this, 3.2, because for me PCA is 1.1. So this is like, so it is, yeah, so it's a 3.2. Okay, so there is like a questions will come in this exam, maybe, what is the goal of this your clustering. So this is your goal, you have to minimize your this equation by considering z1 till zn, and what this should be minimum summation of xi minus mu zi. Okay, it's a zi, always remember. And there the questions may also ask what is the mean. Mean is nothing but that what I give you the formula of the mean here. Okay, this is a mean, this formula. Okay, just remember this formula with this example, whatever now we have this example. Okay, mu1, how you calculated, you checked which is having 1 as a cluster, you get the cluster and divide by how many number of mu these clusters are there, how many points are there belongs to that cluster. 3 points here, 2 points, that's why mu2. Okay, so these kind of questions may ask in the exam for this kind of 3.1 session. Now this LLYODS algorithm, we now understood this terminology. Okay, z zi till 3.0 you understood, like what is zi saying z1, z2, z3 and so on till z4. What is this? It is saying that x1 has this x1 point has some cluster indicator called as z1, x2 point has some cluster indicator called as z2, x3 also has same way, and xn here, xn also has same way, zn cluster indicator. That may be z1 is equal to 2, z2 equal to 1, z3 equal to 1, zn equal to 2. Maybe if I am having k equal to 2 clusters only. Example, okay, this is the example. So you understood zi, but what now next point what we discussed, we understood that because if you are creating some groups, okay, and you are saying I am for example this is one group, this is another group, and this is one group, okay. You added this point here, this is the mean of the group. I am saying the red dot is the mean of each group, okay, mean of the each group is called as mu1, mu2, mu3. These are the mean of the each group, each clusters, okay. For the visualization I am just showing you just to understand you, okay. And this is one point in the blue dot. I will show you this is the point. I am saying okay, this point belongs to mu1 and not to mu2. But if you see actually the distance between this mu and this point, if, for example, this point is called as x, the distance between this and this is a, distance between this and this is b, okay. So what is smaller here? B is smaller, correct? P is smaller than A. So you, whatever this clustering you have created, this is not the correct cluster. This shows that it is not the correct cluster. So what you need to do? Now you need to change that cluster and create a new cluster which is including this point. So what you did now? You are having this mu1, which is like new mu1. It is earlier mu1 is with these many points, all these points are included and they created mu1. But now what, they reduce the points. Now this point is went into the other one, so this is now new mu1, okay. This is not the old same mu1, it is like a new mu1 for this. And this mu2 is also increased because this new point is now here in this included, or the blue color, okay. This is x, okay, this is mu2 and this is mu3. Now this is included here, so this has a new mean, and now this cluster is changed. This cluster is changed. Earlier the x has here, the x has, this x has z x1, for example this is x1 has z1, okay. Means what I am saying, this x1 point has a cluster indicator z1 which is equal to what, is equal to this cluster. I am saying about this example, okay. Oh, I think I should write straight. I will just draw another small, okay. So this is a mean, this is mean, this is mean, this is mu1, mu2, mu3, okay. This is cluster 1, cluster 2, cluster 3, and this is a problem point, is x point, okay. And calculated the distance between this and here, okay, and then here also. And I said this is A, this is B, and this is C, and you figure out that B is less than A. Means next point, next time you, what you did, you created another cluster mu1 dash, and this is the same mu2, but this should be bigger one because now it is including the mu2, and this is alone mu3, okay. And this point is now here inside this point is now included here, okay. And this is now your B distance, and you are now happy with this. But when this x1, when this x1 point was here, that has a cluster indicator z1 which is nothing but your 1, that was one value. But now when you calculated the distance, you found this distance is this distance is A is like bigger than B, and B is smaller, so you add x1 to the mu2 cluster, okay, mu2 cluster. And now you are saying this whatever x1 is here in this iteration, okay, in this iteration, this is I equal to 0, and this is what I equal to 1, next iteration, okay. You are saying now x1 has a cluster indicator z1, now it has a value 2, it has a value 2 here, okay, it has now value 2. But see, here also x z1, here also z1, and in some kind of solution, and if you are doing some proof, okay, if you are solving something, then if you write the z1 only, then you will get confused whether it belongs to this iteration number 0 or iteration number 1. Okay, that's the confusion. So that's why for when you go to this LLYODS algorithm and all, so these terms will come. Okay, so the terms are something z, what is, you know that, okay, z, and you know 1 2 3 4, how you did 1, like z1 z2, that's fine. Okay, z1 z2 z3, so on. But what, how to say that whether it's iteration 0 or iteration 1? You are having this iteration index here, z0 z2 z1 0 z2 0 z3 0, okay, in here. So it will be z1 of 0, first iteration it has one value. What happened, this is z, okay, this is z. What happened for the second iteration? So z1 of second iteration, which is now 2. So that is nothing but z z, and this 1 1 2 3 4 5, this value is represented by your I, like I is equal to what, 1, like number of points you are having 1 to 100. Okay, x1 till x100, so you are having z1 till z100 also. So that's I value. Okay, that I. And what about here? Because you are having this 0, next iteration it will be 1, next iteration it will be 2 also. Okay, so that is nothing but your t. So I am representing the iteration by t. Okay, so that's why it's called as like, so the representation, you just now remember, understand that what is this representation. So it is nothing but your z, saying that your cluster indicator of the point I, like I will be z1 is x1 cluster indicator, z2 is x2 cluster indicator, like this. Okay, sorry, z2 is x1 x2 cluster indicator. Okay, z2 belongs to here x2 has cluster indicator 2. Okay, but which iteration? So I am saying iteration number t is equal to, like this, z2 of 1. So cluster indicator of x1 is z1 and second iteration. Okay, so just remember, because now we'll go to the solution of your LLYODS algorithm. Okay, so this you need to understand. Okay, so first step in the LLYODS algorithm, first step is what? First step of your LLYODS algorithm. First step is you need to, like, see, z1 z2 we just earlier initialize with 1 2 3 4, means you have to initialize the z1 and z2 with some value. Initialization. Okay, you have to initialize with some value. Okay, that is up to you, like how you are initializing. Okay, so I am initializing in first step, I am initializing the cluster indicator, means I am saying z1 and z2 is equal to what, z3, and so on. How many points I am having, that many indicators I am just initializing in the first iteration or first step. Okay, this is a stage or step. Okay, first step, and 0 is like at the initial time. Okay, and this belongs to what, 1 to k. So that what I just said, z1 or z2 is equal to, how many you are having, two boxes. So either z1 is 1, z2 is 2, or 2 or 1, or both are 2 2. Okay, different combinations. Okay, so this you need to initialize z1. Okay, but what happened now, the point, second step is very important now, like the point you need to understand, whatever the points you have created now, the points you are, like here as per this diagram I showed you, this circle. Okay, this circle, now I jump x1, and now x1 is now in this group, this bigger circle is now removed, it becomes small in the second stage, this become like a small circle here. Okay, and this is like your x2 second cluster. Okay, which increases because the distance is here. But how many times, like for x1 x2 is sufficient, or like if there are too many points I need to jump for every point, then is it something like every time I am jumping, and because I have to wait at one point, I have to stop at one point, I should be happy that okay, whatever the jumps I have done now, the jumps are happy, like these are the correct places where the point should be, this is the correct boxes where the points or where the item should go. Okay, you are happy. So how many times? So it should be going to the converge. Like how many times you have to jump until convergence? Until convergence, until convergence, you have to what? Until convergence, you have to jump from this group to next group here. From this you like, okay, this is best one. Okay, so you have to not only check this point, for this point maybe it's best, but you are having so many points, you have to check for other points also whether there is another group. Okay, here also, so you have to check. So you have to see and jump, you have to jump, and one point you have to step, you have to come and stable, jump, jump, jump. Okay, now I'm happy with this jump, and whatever now this iteration I am getting these clusters with the points that are the best clusters, and I'm happy. So that is called as a convergence. Till what you have to jump till you feel it's like a converge, or till you feel it's like a you are happy. But how we say that, how we say it's like happy? So we have like a goodness indicator, correct? So we have the points what we checked earlier, this goodness of the points, that's what we have this formula, the goal what we have, like xi minus mu zi whole square, and the summation of I equal to 1 to n, this should be minimum. And this is your, this is what, this is your goodness indicator. Okay, goodness of the partition. Okay, but what happened now, here it comes saying that mu of zi, mu of zi means what, you have to calculate, you have to calculate mean, you have to calculate mean at every jump. Like once you do the jump, like here the circle which I showed you here, this mean, because I just mentioned you this circle, this circle here, this circle has has earlier mean as a mu1, but now I found that x1 belongs to this mu2, this group cluster 2. So I just increased this circle bigger, I made this circle 2 bigger and made this circle 1 smaller, means the mean is changed now, the mean of, or the average of this cluster is now moved, is changed now. So you have to calculate one more time this mean, you have to calculate one more time the mean of this middle circle mu2, correct? So you have to calculate mean every step, every iteration you have to calculate the mean. Okay, you have to calculate mean. First point, you have to initialize your cluster indicator, like earlier any initialization, x1 belongs to 1, x2 belongs to 2, randomly you can say x3 belongs to 1, x4 belongs to 1, like randomly you can say. Next point, you have to see that you have to calculate the mean for every iteration or every loop, you have to calculate the mean, which is nothing but mean is what, okay, mean is nothing but your summation I equal to 1 to n. And you know the formula, just I am just writing here one more time. It's yeah, this is the LLYODS algorithm. Yes, so your step 1 is for your LLYODS algorithm. So LLYODS algorithm, because let me write this and then I will say you. See, the cluster indicator, you have to calculate mean at each step. So what is this LLYODS algorithm saying? That you are having 10,000 points, like for example I mentioned you are having 10,000 points, you have to put the 10,000 points in such a group into only two boxes, box number 1 or box number 2, or two clusters, cluster number 1 or cluster number 2. But in what combinations you will put, that combination is nothing but your k raised to n. K is what, 2 raised to n is what, maybe 10,000 points, 2 raised to 10,000. These many combinations are there, that many combinations are there, and you have to choose the combination which give you the minimum of this value, minimum of this goodness score. Okay, goodness score, which give you the minimum of this summation of I equal to 1 to n xi minus mu zi whole square. Okay, you have to get that value, the minimum value. That combination is the best combination for your clustering. But you will say that is 2 raised to 10,000 means is too much, so that's why we call this one as a NP hard problem. So to solve this NP-hard problem, we are having algorithm called as a LLYODS algorithm. Okay, which will give you the what is the best cluster for the given data points, like whatever data points you are having, how you will separate the data points, and you are now finally you will feel happy that okay, whatever the separation or whatever the clustering things I have done, how I created the clusters of the data points, how I just put the data points into different groups, and I am now satisfied. So how you say satisfied? For that there is an algorithm called as LLYODS algorithm, which will help you to derive whether your cluster is correct or not correct. Okay, and that LLYODS algorithm, first step is you just initialize the cluster indicator of every point. Like you are having x1, x2, x3, x4, any point, you are just simply saying x1 should go to box number 1, x2 should go to box number 2, x3 should go to box number 1. Simply you are randomly saying like this. Okay, you are randomly first step you are saying, that's the initialization stage. Okay, and whenever you say like this, so you are now having one cluster indicator z1, z1 and z1 of 0, z2 of 0 means 0 means what, iteration, like first iteration I am saying, z3 having some value, you are having this cluster indicator. With that cluster indicator you need to calculate the mean of your each cluster. Okay, at the first level of cluster, this mean, how you are calculating the mean calculation is having this formula, summation of I equal to 1 to n xi into this indicator function that I mentioned, x1 plus x3 plus x5 divided by 3 and x2 plus x4 divided by x2 plus x4 divided by 2. Okay, so this way uh, what happened to this? Okay, sometimes this pen disconnect from the board and I need to figure out what to do this one. Okay, so I will recheck that, but the point is, the main important point is you have to figure out the mean after it got converged. Like you are just checking, first point is my pen is not working this. Which one? Actually just doing the same, disconnect and connecting. It's okay. Let me just disconnect one more time, okay, and just close this one. I hope it's saved also. If I close it, okay, what we are saying, so until convergence, like first group you created and you are now happy with this group or not, or you are not happy, then what you did, you, okay, this is okay, the first yeah, I think I should open this. It's fine. So every step we have to calculate the mean, so that mean calculation is the uh, yeah, it is there, I hope. And now the important point is it should now work also. uh, okay, okay, fine, luckily it started, good. So yeah, this is the important algorithm. Okay, means like if you understood this one, then you understood k-means cluster, that's all. Okay, so every step you are now calculating the mean. Okay, that first level you calculated the x minus for this, for getting this value, for calculating this goodness you need mu is what, the mean of that level. So that's why our first circle was like this. I have showed you this point. So instead of this point here, that this is the iteration first circle. Okay, when z1 of this zero iteration was 1, 2 and 3 is equal to 1, and you are not happy because the distance between these points, the distance of this point is a, and this is like sorry, I took a here and this is like a b. So I understood, like in the iteration 1 b is small than a, so you want now this is mu1, mu2 and mu3, and you want now this should mu1, this point should come and go into the another cluster 2, but with that size of cluster it can't go. So it has this cluster 2 has to go increasing, so it has to go bigger. Okay, mu2, and this b point should come now here. Okay, once you this change, so your this mu1 will go smaller. Okay, mu will go smaller, and this mu3 here. Okay, so means every point you are changing this, you are calculating the mean value. Here also in this stage you are calculating the mean value. Maybe there is some more point which is here, which is very near to your cluster 3 and it is in cluster 2, so then you have to calculate the next level. You have to calculate the next mu2 here because it belongs to mu3. So every stage you are calculating mean, so that mean calculation you are calculating. So how many stage you have to do till it converges, till you feel that the final jump is fine, like you are happy with the final jump now. Well, from one cluster to two cluster to three cluster, it's final, is that you are happy now. Okay, so till that it will be calculating the mean, and mean calculation is given. But once you say that I am happy, I went to the cluster number 2, and then you figure out that whatever cluster 2 I am now here, it is not good, because I should not go to cluster 2 also. I should now go to maybe cluster 3. Okay, because the distance between cluster this x point and the cluster 3 is smaller than cluster 2, and you found that okay, instead of 2 I will jump to cluster 3, and then this way you are just simply jumping. Okay, and after cluster 3 you found that okay, cluster 1 is only better, I don't like now, because the cluster 1 is better means what, you are calculating the mean every time, means the mean is changed now. You don't think the cluster 1 at the first level you are, whatever the mean you are having, or the same cluster, it's not the same cluster now, it's completely changed. The bigger circle becomes smaller, or in next iteration it will become different shape. Okay, now the clusters are changing, so you are every time checking, should I go to mu1 now, then you come to mu1, and if it is repeating, if you are like going from mu1 to mu2, like mu1 means cluster 1, okay, cluster 2 for example here I'm saying, okay, mu2 means the mean of your cluster 2, but just I am showing that is one cluster, and you are once again going to mu3. Okay, and then you are coming back to mu1, and same way now you are just jumping like this. You are not happy now, you are not happy at any stage, you are just simply jumping mu1 to mu2, and it is now in a circle. Okay, so that kind of points are not converged. Okay, this point is not called as a converge point. Okay, they never converges, never converges, this point never converges, they are always be in a loop. Okay, okay, so they are changing from mu1 to mu2, they are changing from this partition to this partition, or this cluster to this cluster. Okay, they are changing, you will be happy, okay sir, they are jumping from mu1 to mu2, now they are jumping from cluster 1 to cluster 2, or cluster 2 to cluster 3, they are jumping. Though they are jumping, but they are not happy with that jump also. Once they understood I am not having enough distance with the mean and my point, so you will all try to check with another, and it's like infinite, like not infinite, but it's just simply rotating, going here and there. So this point never converges. Okay, this point never converges. The points which are jumped and they are like jumping in a loop, they never converges. Though they change the partition, they never converges. Okay, so but what happened, like jumping from here to there, the second point, second step is what, until converges you calculate a mean, but you have to check this distance, and then you have to reassignment also. Okay, I will use I'll use the same color pen here, red. This is called as reassignment. You understood, like a first point was calculate the mean, which is every time, but now second stage, your circles or your value cluster shape is changed. Now once again you have to calculate this mean. Means you have to not only calculate the mean, you have to also calculate your cluster indicator, because this time cluster indicator was here z equal to, this time it was z equal to 1, but now here your same point is now becoming 2. Means you are calculating your cluster indicator. What it's it should not be I equal to 0, it should be I equal to 1, because it's the next iteration, correct? Earlier it was 0 here, earlier this was here z of 0 of 1, but now this z of 1, because next iteration, this is 1, the next iteration showing the next iteration of the cluster 1, which is now having 2 values, correct? So in the reassignment for all value of I, means for all points, okay, for all points your zi of t plus 1. Earlier what, like here I just showed z0, z1 of 0 is 1, z1 of 1 is 2 now. So this iteration is changing. So zt plus 1, because 0 is becoming 1, so zt plus 1 should give you arg k minimum of xi minus mu k of t. This is a reassignment, okay? This formula you should like, these things you should now remember here in the reassignment. This is separately point, okay? In the reassignment, so what is now happening, you are comparing the mean value, and then you are creating, like here you are compared with what, here you are comparing with your own mu1. Earlier this x1 point, you thought that I am happy with the mu1, the mu1 is your current mean, and you are also comparing with this value mu2 parallelly, and also you are comparing with mu3 also here, mu3, and you found that this mu1 and x1, the distance between that is a, and this is like a b, this mu x and mu2 is b, maybe c is also there, and you found that whatever my current situation is there, wherever my current cluster cluster 1 is there, that distance is a, and that is like bigger than the distance between the next mean. This is different mean, okay? This is different mean. This is a bigger circle with a mu1 mean, and this is a smaller circle with mu2 mean, okay? So what you are doing here in the formula, if you come and see, you are not only checking the mean of your own circle, you are also checking the mean with your neighbors, okay? You are also checking the mean with your neighbors, okay? So once you found that my mean is like smaller with the my neighbor, then you just jump to the new cluster, like cluster number 2 in this iteration. It jumped to cluster number 2 here. So that's why z1 become z2. What is z11? This is what, this 1, okay? This is iteration 2. But how you got this one? Who said you, like you come to this cluster? Who said you? When I was in this earlier iteration, when I was in old stage, my earlier stage, when I was in the iteration 0, I checked my point, like x point, this point say that I check myself and the distance of the mean. I check the distance between this mean of my current cluster. This is his current cluster, correct? This B has the current cluster, this one. It checked the distance between its mean, current cluster mean, and itself, and it found that value is a, and it also checked the distance between the neighboring cluster mu2 and itself, and it found that value is b. So depends upon this stage result, iteration 0 result, which is like, for example, if it is a t, and then it is like a t plus 1. So at iteration t, it checked the distance between the neighboring cluster, okay, mu tk, okay? It check the neighboring cluster and figure out, okay, my distance is like smaller with the neighboring cluster. I jump to that, okay? And this decision happened in the next iteration. T plus 1 is, you are able to see this decision, But this decision, when you got the decision in the earlier iteration itself, in the earlier level itself, you understood that my distance between my neighbors is like smaller, so I should just jump to the my neighboring cluster instead of my current cluster. So that decision happened in the earlier iteration. That's why you can see here it's a t plus 1. It's like t plus 1 means what? Your current iteration. Okay, t plus 1 is your current iteration, or this is cluster indicator, because here this z1 of 1 is now 2. This value is 2. Okay, and this cluster indicator depends upon your mean of your earlier cluster indicator, like whatever is mean. So its mean is here, mu t. Okay, it's not t plus 1, so it depends upon your earlier indicator. Okay, and that earlier indicator is here. So what I just showed you in the here, t. Okay, so once you found that my mean with my neighbor is smaller, and I found the distance of myself with my neighbors is like a smaller, then you are like now deciding your next cluster indicator is with this formula. So you need some argument of k. K means what? K means your indicator, cluster indicator. So your mu1 or mu2. Okay, so k means what? Here in this case you need to figure out which k is good for you. This guy earlier, this guy having earlier this guy is saying that he is x, he comparing with this mu1, and he found that instead of that I will just go to mu2. So k is saying should I go with k1? K is, if it is k is equal to 1, it is like a mu1. If k equal to 2, it is like a mu2. So it's saying that I need the k argument, I need the argument k which gives me minimum of xi minus mu k, this xi minus mu k of tth iterations square. Okay, so give me the value of k, give me k equal to 1 or 2, that's okay, I don't have problem. Give me the value of k which give me the minimum value of xi minus mu t k whole square. Okay, that's why I need the argument k which give me minimum value of xi minus mu t k whole square. Okay, and mu t k means what? This is the mean of your cluster where you are belongs to. And in next stage what happened in next iteration, I want to go to t plus 1 iteration. That's why it said that z of t plus 1 of the same data point. For example, here I will say 1, here they say I means it will go for all value of I. That's why I said all value of I. So for next iteration 1, if this is the formula. Okay, so if you say that my consider you forget about this point, now whatever explanation what I have given these points, that's fine. Okay, that's fine, this point is now moved, you forget now this point. You are now having, for example, here the other point, the blue color point. Okay, and this is the mean mu1. Anyway, because if you check this distance, and if you check this distance, this is, in this case this is the d and this is e. E is anyway smaller than d, means for this point this cluster is happy, like he is happy with this cluster mu1 cluster, or this cluster 1 c1 cluster. This point is, maybe it's like, for example, it's like a x5 point. X5 point is happy with the cluster 1. Okay, if it is happy with the cluster 1, he will not jump, he will not go to the cluster 2 and cluster 3 or what maybe. Okay, it won't go to cluster 2 or cluster 3, it will simply stay as it is there. Okay, because the distance between the cluster and its current mean is smaller. So in the next iteration also it will be the same, like for this x5, for the x5, so z5 is 1 in earlier iteration. For this next iteration also, t equal to 1 also, for the x5 z5 is still 1. Okay, next iteration also, because in the reassignment he is saying that I am happy with the current cluster position, so no need to just reassign me the new cluster value. I am happy with my current group, so I am not jumping now to another group. Let it be in the same group. Okay, so in the reassignment there also it happens, but it will be same as it is. The z, this value, like whatever this zi t plus 1, this value will be as it is for that points. But the points which are like this example, this circle examples which I mentioned here, for this point you will get the reassignment value, and the formula is here. So you want xi minus mu tk whole square, the distance of your point with the with the mean of your earlier iteration. Okay, this is t iteration with your neighbor. Maybe he's checking the neighbor iteration, and he found that okay, neighboring iteration, neighboring cluster having this distance is less, so I don't want to stay here. So in the next iteration, t plus 1 iteration, he just jumped to the cluster number 2. But cluster number 2, how he got, it depends upon the earlier result, like this result depends upon the earlier result, means this mean of your earlier cluster has this mu t mean, and with that he just calculated the new cluster indicator value for that. Okay, so this is the actually the LLYODS algorithm, but there are the points, because LLYODS algorithm is like only 2 steps, but you have to know what are these 2 points, what are the next points, because it looks very easy algorithm. First is just give some initialization. You just initialize your cluster indicator with some value, and you are saying that okay, once initialize, I need to calculate mean, and once you get the mu k, this is the mean. Okay, this is the mean. Okay, and once you get the mean, you are like here. Now you can here. Okay, once you get the mean, you are using that mean and subtracting the points, xi minus that mean value. You're subtracting means you are figuring out the distance. Okay, distance of your point from that mean you are figuring out, and once you feel that the points is the distance is less with my neighbors, then you jump to that neighbor, otherwise you stay there. So in the reassignment, this is reassignment step, where you are reassigning the cluster indicator. If your neighboring having minimum distance with you, then you just jump to that neighbor, otherwise you stay there. Okay, this is the LLYODS algorithm, but this week 2 won't end here. It is the starting of week 2. Okay, so we have to figure out whether LLYODS also correct or not. So this is the point you need to first understand. But before that, you understood the what are the stages of the LLYODS algorithm or not. So this is the LLYODS algorithm. Any question till here? Anyone? Any question? Okay, so we have few points to mention. Okay, because then tomorrow will be easy to finish this case. Okay, so now the second problem. Now problem not, but you are now happy with the k-means algorithm or the LLYODS algorithm. That LLYODS algorithm is also called as k-means algorithm. So you are happy with the clustering LLYODS algorithm. You are happy, but LLYODS algorithm, because see, you want to jump from this to another cluster and another cluster and another cluster, and at one point you should be happy, correct? It should converge, it should go to your end, it should actually go and jump go and it should be it should be in a piece, that okay, whatever the final cluster I got, my group I got, I'm happy with that. Now I am satisfied. So some this type of feeling should come. So that what this feeling word, we should not use the feeling word, but the word in our mathematical form is called as convergence. So it should converge. Yeah, tell me, ma'am. Yeah, tell. Okay. Yes, that's correct. That's true. But okay, that's true. That you are asking the correct questions here. That your answer will be also hidden here. So whenever, because you understood the formula is k raised to n. Okay, two data points, and if 10,000 1,000 points are there, so that is taking too much time. But that is called as the actual minima. You know this local minima and the actual minima. So what happened when you are trying to converge? Okay, you are now somewhere here, and you want to go to this point. Okay, maybe I'll just draw the graph here in the center. So here, okay, so out of these 2 raised to 10,000, you are getting some combination of this x1, whatever may be the values, or these x1 till x 1,000 points are there. You need to put into the two clusters, and you need to figure out the minimum value of xi minus mu zi whole square, that summation of that. Okay, and you got some value here, and you say that here this is the value. Okay, just visualize, okay, and your point is here, okay, means you want to come to this point, okay, you want to come this point. This is just for your visualization, okay, so it will be easy for you to understand, okay, and this is your goal, means you want to converge. This is called as convergence, okay. Convergence means you want to just come and stay here, this come and stay here, means you will feel peace in your mind. But the point is, how many times I need to come, how many times I need to search. I need to search 2 days to 10,000 times I need to do, then I will come to this final point, okay. But is it worth, like, because it's very time complex consuming, and it's good to go till here, or do we have any other our own way of feeling happy? So it say that, okay, if you want to just not to convert to this point, global convergence point, or this convergence point, so okay, this like minima, this is global minima, you can say, okay, the global minima is your convergence point. But if you don't want to do that, so what we'll do, we'll just go here, we'll be happy like this. So instead of going to here, you go till here, that's all. You try to achieve your some part of like a local minima with this, okay, and you try to come here and say that, okay, I achieved something here, and with this one I am able to create some cluster groups. Maybe see, there are outliers, there is like you are having some points here, here, okay, here, okay, and there is unnecessarily one red point, okay, and you are also having the other points here, here. You are happy that you are able to create a cluster, you are able to like differentiate between the PCR. Or you say that this side is like this side, this cluster is belongs to red, and this cluster is belong to green, you say like this. But the point is what, this is the extra point is coming now here, this is the extra point, and for that point whatever the clustering things you have done is not the perfect one, because this point belongs to this red point, is not belongs to the green cluster, green zone. This red point is not belong to your green zone. So this whatever the clusters you created, that is not the correct one for that. But for this, then you have to figure out what is the best cluster, means you have to once again like do if I do this graph, and then you have to figure out the non-linear kind of line or group for the clusters, okay, something like this, and others are green points, okay. So you will do that, like then you have to figure out 2 raised to maybe 10,000 ways, figure out which ways is the best to have all the rates. But instead of that, for some outliers or for some points, you will say that, okay, I want to go till some value of cluster where I feel maybe not 100% peace, but I feel some kind of a peace, okay. So for that reason I will go to the local minima instead of the global minima, okay. So you can go and stop at the global minima, sorry, local minima. Yes, yes. For example, ma'am, because this what we took is like examples we took. For example, if you get the data from your Mars, okay, or our Chandrayaan send you some data, okay, and there was some problem happened that sensor doesn't receive the data properly and gives some, maybe because of some random issues, maybe electromagnetic waves and like different issues. The data is total random, and that data is not actual data, but still you get the data in your, like, once you get the data in your station, you downloaded the data into your CSV file, and you found that all data are like very base data and all, and immediately in that one digit data, okay, and in out of one digit data you found there is another data is like a 10,000, and you found, okay, what is this data, like, is it like something happened in the space, like there is abnormal situation happen in the space or something, or is it like the wrong, because of our machine sensor some wrong data came. But because of that data, if you need to calculate, if you need to separate out the data, because if you see this clustering now, so this we go like we create, for example, these are the clusters, we create a box, like in, if you see in SVM and all, so we create this kind of a box, okay, to differentiate between these two. And there is some wrong outlier here, so what we do, we'll just make it half, okay, and then once again we'll try to see in between these two, okay, and then once again you found that, okay, here also there are green points are here, there are green points here, so you will create another small box here. So means this is like now green parts, and only this one is the red, and you try to create a cluster with these all red boxes like this. So it means you are thinking about, it's like outlier, and you are trying to do overfitting here. This is called as overfitting. So you are trying to take all the points, make sure that they are going in, they should go into the proper group. Means that will go for the overfitting, but yeah, that is something different. But it's okay. You can calculate that. It's fine. But the problem is it's taking time, and you don't want to like take that much of time to just to make the cluster. So in this case, we use this LLYODS algorithm. But LLYODS algorithm, whatever the output you are getting, it is not also going to the global minima. It's not going to the actual convergence, but it will go to some extent of the convergence, like a local minima. Is go till that extent, and then you will feel that, okay, because at least whatever the groups you are now having, you can create the group of green points here, and there are like a red points here, and maybe there is blue points here, something. You have created the groups, and you are now happy with that. And maybe if there is something by mistake, some points are here, like you say, okay, because if you want to go there for that single or for that 2-3 points, you have to once again iterate your algorithm for complete. Because see, next iteration, what you are doing, you are in the next iteration for that 2 points, you are doing iteration, means what, you are calculating the mean value. Also you are using this your new cluster indicator, and then you are calculating xi minus mu I whole square. You are once again doing for that many all the values, and unnecessarily, because these points are already there, these red color points are already there in the cluster, but once again they will have to go through the same step. They will be there in the same one, in next step also they will be there, they will sitting in the red cluster. But problem is, once again you have to calculate for these only 2 points. Okay, so that's the reason to like, we don't want like 100% convergence, but we want some extent of convergence. So this algorithm, now this whatever the LLYODS algorithm we are having, we have the LLYODS algorithm, but we have to ask few questions to the LLYODS algorithm, because this is also in the in our sessions, in our week, sir mentioned that LLYODS algorithm, whatever we are having, you have to ask below questions. What questions you have to ask? Whether are you converging? Okay, whether you should ask to the LLYODS algorithm. If LLYODS algorithm consider he is a person, and he's guy, okay, and you are asking this guy, are you converging? First question, okay, he is LLYODS. Okay, second question is, what is the nature of your cluster? Like whatever the cluster you are creating, nature of clusters. Okay, nature of cluster, what type of cluster is producing. For example, I mentioned, so if these points are there, so you can say it is a red point and this is a green points, and you just simply create a cluster like this. Okay, if it is like if you need to create a 3 clusters, if you need to create a 3 clusters, it will be something like this, red, green and blue. Okay, this is your nature of the clusters, depends upon your clustering, whether 2 cluster, 3 clusters and all. Okay, nature of cluster. Your next question will be like, you initialize with some random value, as I mentioned, z0 is equal to, in first iteration, z of 1 is like 2, z of, in first iteration, z of 2 is like 1, like randomly I was initializing. So is there any way how we can properly initialization of your cluster indicator of z? Okay, how can I initialize this algorithm? Okay, and then the last one is, because whenever I mentioned you the points x1, x2, and I also mentioned k equal to 2. Okay, k equal to 2 I mentioned, but k equal to 2, how I decided whether should I go for k equal to 2 or k equal to 3? Like someone has to give me the value. Okay, like what choice of k I should choose, like k equal to 2 should I choose or k equal to 3? If I'm going to the, if you are handling a DMART data, Okay, so then you are having what, you are having your electronic data, then your like the clothes kind of data, then groceries kind of data. So you are having clusters, like electronic will go into one cluster, clothes will go to another, your vegetable section will go in some another. Okay, so you are having some groups, means you are deriving yourself, like I want some 5 groups, one should be electronic, one should be class, and one should be vegetables, one should be your javari and all these things, wheats and all. Okay, so that you are deciding, but in this way we have to decide what is the choice of k, like how many k, one cluster, two cluster, three cluster, five cluster, how many k I should do. So we have to ask the questions to this Lloyd's algorithm. First is whether you are really converging. You are really converging means, because finally we want like a global minima, that is our main intention. Okay, if it is like too many points are there and you want to differentiate in that two clusters, then that many iterations happen, means you need to converge that. You should not like simply, as I should give one example also, you are just jumping from here to here, here to here. Okay, once again you are just, it's like a loop, but you are not converging. It is like it is like a jumping from here to there, but not converging. So this is not a convergence. Convergence means at one point it will come and come to thinking that okay, I am having peace now, I am happy with the current group. So that is convergence. So whether Lloyd's algorithm should is converging or not, or what is the nature of clusters, like clusters, as I said you, it's like a 2 clusters, or it's like a 3 clusters, something like this. Okay, initialization of your zi value, like whatever the first initialization we did, what is the first initialization you have want, so that should be a better initialization you have to do, so with some kind of logic. And the choice of clusters, like how many clusters we are having. So this is something we need to ask the question to the Lloyd's algorithm. But just the first point, okay, because we are anyway, we finalize the Lloyd's algorithm is like a converging. Lloyd's algorithm converges, that is the fact. Okay, that is the fact, means you no need to like uh, once again derive whether he is, once again decide whether he is converging or not. You should not suspect whether Lloyd's algorithm is converging or not. So I'm directly giving you the answer that Lloyd's algorithm converges. Okay, Lloyd's algorithm converges. That's all. You see, it converges. Definitely, it will bring you to the some feeling that whatever the clusters you are created, okay, that clusters are like okay. Means this whatever the clusters you got, that clusters are not too bad. It's okay. They are like a good representation of the group of the data. It's not 100%, as I mentioned you, it's not like global minimum, but it's like at good level, it's like okay, accepted kind of a clusters. Okay, so Lloyd's algorithm converges. So out of these 1, 2, 3, 4 questions, first was your convergence, and we mentioned that fact that the Lloyd's algorithm converges, and we have to now see. And once we find, well, like we have to see whether it's converges or not. And once we finish this, we'll stop this session. Okay, but this is the first point is convergence. Okay, so does the Lloyd's algorithm converges or not? So you have two options, yes or no. The answer is yes. Okay, so any question till now here, in if is there, we will take. I'll be, because it's small derivations, but it's like little important derivations for this Lloyd's algorithm. Mm, okay, so we'll go to the first point, that is like convergence. And okay, so we decided, we try to figure out whether it converges or not, and we understood that from the fact that it converges means we got the answer, it converges. Okay, and how this is happening, okay, it's like we have some kind of because this is machine learning is not simply by your own mind, it will not run, it has to give some kind of a proof in math. So then only we can say that okay, whatever the point you mentioned, it's like a perfectly fine, or I am happy with, or is the solution is correct. Okay, so we are now proving that fact, whatever the fact we mentioned, that Lloyd's algorithm converges. Okay, that fact we are proving. Okay, here this fact we are proving. Okay, let's say we have points like x1, x like x1, x2, so on till xl. Instead of xn I am saying xn, I am saying xl. Okay, l points. Okay, and or like belongs to rd. Okay, there are some points, it's not like some fixed point, they are like now random points. Okay, and now what we want to find out, we need to figure out, one point in this given point, in this, these are the points. Okay, these are the points. In these points, we need to find one point. In this one we need to find one point. I will just write here. Okay, now we want to find out one point. What is that? Maybe this point is called as v star. You need to figure out one point, that is v star. Okay, what is that point? V star. V star means like any v star? No, the v star. Okay, that value of v star, or the value of v, because it's a value of v, and that v is something like v star I am saying. Okay, the value of v which minimizes the sum of square of distance. Okay, the same when what we have seen. Okay, what we have seen, you have to figure out sum of, what is sum? Sum of square of the distance. What is distance? Distance is xi minus v. So you have to find out some value which is nothing but your argument. What argument? V argument. You have to figure out which is belongs to rd. Okay, it's like a vector. Okay, you have to find out value of v which give you the minimum of this, because we are anyway aware about this. You need a minimum value of this equation by using some value of v. Earlier what we used to take, x minus mu, correct, mu square. This is mean, we said this is the mean, correct. What is this v? Indirectly this is also mean, but we have to say this is mean or not, so that derivations we have to do. So what we generally do in this kind of derivation, like you need to figure out the minimum value, you need to find out the value of v which gives the minimum of this summation of xi minus v square, like a sum of sum of square of your distance should have the minimum value. Okay, how you will figure out? Generally what we do, because this is a vector. Okay, this is a vector belongs to rd. Okay, so what we generally do, we take this f of u, derivative of this, and equate to the 0, correct. So let's do it quickly. Let's do it. Okay, what we'll do, the main objective function is what? Objective function is here summation of xi minus v whole square, correct. I equal to 1 to n, because here l points we mentioned, so we take l. I is equal to 1 to l. Okay, so what this is one function j of v. This is objective functions. Okay, in terms of v, because here I take v, so it's some functions. F of v also I can take, like maybe for you is f of v. I will just f of v. Okay, so what happened here, how you can write xi minus v whole square? Like it's like, for example, a minus b whole square is same thing, a square minus 2ab plus b square, as these are the vectors, because v is a vector. Okay, so v is a vector because it belongs to r and rd. V belongs to rd, dimensions t. Okay, so this is one vector. How you will write that? If you want to write this one, xi minus v whole square, how you write? Xi minus v transpose, correct? Xi minus v transpose into xi minus v, because vector generally you don't do a into b, a transpose b you will do, so that's why. Okay, a transpose b, something like this. Okay, so what it will do, f of v See, in the lecture you will have directly the solution, the final one, but just I'm just giving you the quick things how this sir has derived this, because in sir's videos he just mentioned you the answer and he asked you to derive yourself. So just I am saying this how it will be something like it. So xi minus xi transpose into xi minus 2 xi transpose v plus v transpose v. Okay, just I am doing this one, the a minus b whole square, which but it is in vector, so it I need to write like this way. Okay, so I'm just now xi transpose just to make the summation for every term. Okay, 2 xi transpose v plus summation of I equal to 1 to L v transpose v. See, v transpose v is what here, these are not belongs to I, like these are not belongs to any data point, so it is like not having any I term. So what is this? It is nothing but what, v transpose v plus v transpose v plus v transpose v. So how many times? Till n times. So instead of writing this, I am writing this as a nv I equal to 1 to L xi transpose x xi minus I equal to 1 to L. So b, what is this? This is called as nv, n v transpose v. Okay, okay. So now this f of v. Okay, so what now, to get this kind of a minimum value, generally when you need to find out the solve this minimum, this kind of equations, you will, what you do, you will differentiate with that variable and equate to the 0, then you will get the answer, the solution. So I am doing the same here, f of v divided by just differentiating this. Okay, and if I differentiate this term, maybe the equation 1, if I differentiate the equation 1, what is this? This is not this is like constant term because there is no v term here, so this derivative will be 0. So here what happened? Okay, here what happened, this v here, okay, this will become 2 will become here I equal to 1 to L, dv by dv will be the 1 here, so it is something like a xi. Okay, the same way, because I'm just not writing trying to see here. So it's like what is v into e, what is this v in, yeah, it comes, but if you just like write, don't write also, because what happened, this equation if you just take out now, it will be something, if I just separately take out these values, it will be something 2 raised to v transpose summation of I equal to 1 to n. This looks like this one if I just separate out the value and put only I value here. Okay, because this transpose is something, I'm just taking this xi value here, and this v transpose, I'm just, you do a transpose b or b transpose a is the same, like he, in this case xi is like a constant, a into x or x into a, see. So that's why here if I just separate out this value now, take out xi outside this v transpose outside this xi, it will be like this, 2 into v transpose t, and then if I just go to the next step, d into 2v transpose v upon dv, it will be 2 into 1, that is 2. So this 2 and this is xi. Just this is like a kind of when you are writing in the vector operation, that's like a, you will do here. Okay, so this is what v transpose v is, what, that's actually v square, like if you don't take a vector, it's v square. What is this derivative? Is a 2v is the derivative of v transpose v. Okay, so you here you will write 2 into this n as it is n v. Okay, 2v. So, and what you said, that if you want to find out the solution of this d of f of v of dv, you are need to equate to 0. So what will happen is nothing but minus 2 into summation of I equal to 1 to L xi plus 2 n v, here this value equal to 0, because I'm just equating to 0. That is nothing but what, if you see that, that is coming as I equal to 1 to L xi. Okay, and this 2 to nv, so these two and these two will get cancelled, correct? These 2 will get cancelled, and what you are getting finally, v is equal to this, v is equal to, I am writing now here, this 1 will go and go in the here, divided by n, okay, this side, into summation of I equal to 1 to L xi. Sorry, I should not take n because we decided to take L. L is number of your points. So here, so sorry, this is like I equal to summation of I equal to 1 to L is going till L, so it should be L times, not n times. So these are like instead of x1 till xn, I am telling x1 till xl. Okay, so L times nv, so it's like L instead of n. Okay, so it is saying me the final value, this n is L. Okay, so this is what the final value will, be L. Oh, what is this? What is this? This is what? This is the average, or this is the mean. What is V? V is like what? Summation of all points divided by total number of points. L points are there. Correct? It is going till L. Summation of all your points divided by L. That is what? That is the mean. Means whatever the formula we mentioned, whatever the point we mentioned that, okay, whatever this point we showed that you need a xi minus, okay, I will just write here. So whatever the point you want to figure out, you need to figure out the point v star, okay, and that v star means the value of that v point, okay, that point which minimize the sum of the square distance here, which minimize the sum of the square distance, and the value here, this value, what will be the value here? This value should be mean. So hence we said that like xi minus mu, we are saying every time xi minus mu whole square. So what this mean? Mu is nothing but your mean. So here we proved that this value is v is nothing but your mean value. Okay, it's like we were using it because of we know that, but hence now we proved that this should be the mean value. Okay, but now because sir has directly given the answer, okay, what he mentioned that this is like you need to find out a point v which gives you the minimum value of your sum of square of distance. Okay, and what is this v point? He directly gave you the answer, v is equal to 1 by L summation of xi, this one, summation of xi, this point, v is what? This is the, he directly, and he asked you to derive, so now we derived it also here. Okay, so this is the average. But so now for example your LLYODS algorithm, okay, your LLYODS algorithm start with some like iteration t, because we know that our iteration start with z1 is here, your initial what at the initial point you mentioned your cluster is belongs to x1 belongs to 2 or something. What is that? Initial iteration 0, correct? But instead of initial iteration 0, we say that we are at some position t iteration. Okay, we are now at the some position t iteration, like we are not at initial level, we are at some iteration point, okay, t. Okay, so I'll say let's say we are at some iteration t, okay, of LLYODS algorithm. Okay, and whatever the current assignments you are now having, what is this? Z1 of that iteration, Z2 of that iteration, Z3 of that iteration, and Zn of that iteration, correct? You are saying that, and these belongs to 1 to k. Okay, okay, these belongs to 1 to k, they are not like simply any values, they are belongs to 1 to k. Okay, and these are the assignments. You are saying now my points are there, I am at some iteration t, I just jumped from 1 to 2, 2 to 3, 3 to 4, I am just jumping. I know that I'm going to converging, but I'm figuring out whether I'm converging or not. So I'm proving I'm converging or not. So for that reason, I'm just giving you the proof. Okay. So in that jumping, I'm at T jump. Means like I jump one time, two times. Now I jumped and now I'm at T jump. Okay. And at that jump, I'm saying now my points are like belongs to this cluster. And what is these clusters? Their indicator is saying here this one. Maybe Z1T is having some value as equal to 2 Z if you are having two clusters. Okay, so he is saying 1 and he is 1 or he is 2 or something. Okay, so these are the just assumption I'm saying. But what values you are now having? You are having value of Z1T, Z2T, Z3T, still ZNT. You are having the values. Okay, and now you are saying that these are my cluster indicators. Okay, and for this given cluster indicator, okay, for this given cluster indicator, you are having the mean. What is the mean for each one? Okay, so because as I said, no, yeah, mu1 and mu2, and these are the iteration. These are the mean of your clusters. Okay, 1 and 2 of tth iteration. Okay, so what is 1 and 2? These are the value. So mean is also here, mu of k. K is 1 or k is equal to 2 of what iteration? Of t iteration. Okay, means of cluster at iteration t. Means of cluster at iteration t. Tth iteration you are having, this is the mean. Okay, but you are now saying that because see I am at iteration t and I am also still now not happy. I know that my algorithm may converge or not. Okay, that I'm not sure, but whatever the current situation I am now having, I'm not happy. I need to jump. Means he is saying that whatever the current my cluster indicator is here, z1 z, like for example point is 1, point is third point, x3 has a cluster indicator z3 of tth iteration. Okay, at tth iteration he is saying maybe my z3 is saying my value is I am having I need to go to 3 clusters, and I am in cluster number 2. I am not happy to stay in cluster number 2. I want to jump. You want to jump means he is not happy in that same cluster. Okay, so he wants to jump. I means he is not yet converged. He has to jump now. Okay, so okay, so we have to figure out that point x3 point, whatever the distance, like this is x3. Okay, and this is a mu1, mu2, mu3. Maybe you can see the distance are not that much easy to say that which is here, which is near, and which is far away. Okay, so for that reason we need to figure out. Okay, so we need to figure out, because s3 is saying I am not happy with my current group. I need to so then our work is we need to figure out which is the minimum distance of x3 from these clusters. For time being, consider it his z3 is having 2, means it is belongs to this cluster. For time being, consider. And it also he is not happy with this distance, a distance. He is not happy with that, and he's saying no, it's like bigger. Just check. I want to jump to another cluster, and you figure out another distance b and c. And now you need to see that whether you should go to mu1, should you go to this mu1 cluster or mu3 cluster into next iteration. Because now you understood this is the wrong cluster for you, for the x3. Now you want to jump to another cluster. For that reason you have to figure out the distance of your point from the other clusters. Okay, so here you need to do the reassignment, because the reassignment things you understood in the LLYODS algorithm. So this is the reassignment steps. Okay, reassignments will come here because your this x3 is not happy. Your current this point is not happy with the current group, so he wants to jump. So the reassignment step will comes here. Okay, so what happened now? First iteration you are now having z1 of t. This is your cluster indicator at a t iteration. But t plus 1 iteration, what happened? At a t iteration you are having z1 of t, z2 of t, z3 of t, and so on. Okay, but you are saying I am not happy. This guy is saying I am not happy. I need to jump to another. Means he want to go to the next iteration, t plus 1 iteration. That will be another value. Z3 has t plus 1, another value. Z2 also has t plus 1. Z1 also has t plus 1. Okay, so they are having different values. Okay, so whether now z x3, for example, x3 went to u3, for example. Okay, he thought that it thought that x3 thought that this group is not belongs to me, I want to go to x this cluster, x3 cluster. Okay, okay, x3 cluster, he wants to go to x3 cluster, this cluster, the blue color one. But is it better, it is like a better to go to x3, or is it better to go to this, sorry, this, is it better to go to x3 this cluster, or should I go to this cluster? X3 is not happy with this mu2, should I go to mu1 or should I go to mu3? Okay, should I go to this different, these two other cluster or not? So we need to figure out which is the better for this. But we, as we know now, so as we know now, whether this means like this, we are making now the partition, x3 should go to mu2, this is one partition, x3 should go to mu3, this is another partition, x3 should go to mu1, or x3 should go to box mu2, because he is already in the box mu2. Okay, mu1, mu2 and mu3, he is already there in the mu2, and x3 is still crying, oh no, this is not my house, I need to go to my proper house. Okay, so he has to figure out which is the best one. So he figure out the distance, he calculated the distance with the other boxes. Okay, other boxes, he figure out the distance. Okay, and then he wants to go to here or here, that we need to find out that. So but we understood, at first point we understood that x3 is not happy, so he wants to he is not converge, he wants to jump. So what happened now here, this one, the distance I equal to 1 to n xi minus mu of t zi t plus 1. Okay, and there is another point, I is equal to 1 to n xi minus mu t, okay, zi t only. Okay, distance. Okay, so what happened now here, square. Okay, what happened now here, this is your current distance. Okay, this is your point, this is your x3, this is your x3. Okay, this is important guys. Okay, this is x3. Okay, and this is your one mean, and this is your another mean. Okay, is mu2 and here is mu3, and maybe here mu1, maybe. Okay, this example, consider this example. Okay, now you are saying that what is this, we need to find out, see, zi of t, zi of t means I is, for example, here is a 2, because we are now I is equal to z3, means like I is equal to 3. Okay, z3 at a t iteration we said that it is equal to 2, means the this belongs to this group here at the current iteration. Okay, at tth iteration he is saying he is belong to mu t. Okay, and x3 means this current iteration, and x3 is not happy with that, means he wants to jump, he either go to mu1 or mu2, means next iteration this x3 is now checking the distance of here with mu2, distance with here, and distance with here, and whichever distance he found is less than the current distance is a, and here is bc. So when he jumps a b, consider you don't have, as of now you don't have c. Okay, when he jumps, when the distance a is greater than b, because he is saying I am now here, my distance with my own mean, the house where I am now living, or the box where I am there, and the box is own mean here mu2, the distance is a, which is bigger, it is far bigger than the distance here. For example, I just draw this. Okay, yeah, so this is the point, this is your here. So this distance is smaller, as compared to this distance, this b. Okay, this is your mu3. So he is saying that this distance is smaller, so I want to jump to that point. I don't want to stay in the same here. Okay, is mu3. So you need to say that what is this? This is the distance. What is it? This is also distance. What is this distance? What is this distance? This distance is of t, means the current iteration. Okay, this mu is what? Your current iteration t. Okay, when he wants to jump to the next, that time he will check that whether distance of my this, he all they are in a current iteration. Okay, he is in a current iteration. He is not yet jumped. He is not yet jumped. He is just checking now the point x3. He is checking now whether the distance are same or not. They all are in the t iteration only. Okay, they are not now moved to the new iteration. They are in the same iteration. So in the same iteration t, okay, in the same iteration t, okay, in the same iteration, this guy is saying, see, I am in the wrong place. Next time in the future, wherever I will go, I want to go to the best place. Means like he is thinking about future. So this is what? This is the future. Okay, this is the future, and this is your current. So he is saying whatever distance I am now having, it is bigger than, this distance is bigger than the distance which I will go in the future. See, he is in the teeth iteration only. Both are in the teeth iteration. The same guy, he is just thinking current situation. He is just thinking when I will go to the next iteration. So Z3 is telling I am now at iteration t. I am having value equal to, as I mentioned, is 2, and he is not happy with that. He is saying once I will go in the future, same Z3 in the future t plus 1, I will go to the another group, maybe 3. Okay, he is same guy but thinking about future. Okay, so that's why this equation, okay, xi minus mu t of zit, this is the square, this is greater than your future. That's why he want to go. If the future is very bad than current, then he don't jump. He will say no, I am happy with my current situation, I don't want to jump. But the current situation is like that, he is not happy with the current cluster, so he wants to jump. That's why he is just imagining in the current iteration t, that next time whenever I go to t plus 1 iteration, I want to go to the 3. Means what? This is like he wants to go to the 3, but how he will go? He has to calculate the mean, correct? That's why the mu value, okay, this mean value, mean of your current t, mean of your current t, zit, okay, mean of your, okay, this one I just write now here. So mean of your current t, okay, current iteration t is greater than your mean of your, like the point, whichever the point x3 is there, x is distance from your mean 3. It's like here I did t plus 1 of t plus 1. Okay, okay, so no, sorry, this should be t. He just imagining that now I am at the t iteration, my mean is here, which is like my distance of myself from this mean of my current is more than my distance from my future group mean. This is his future group mean. Okay, because he can see it like mu3 now itself, but he is thinking that I am going there, so my distance will be like smaller, so I want to jump to that one. Okay, so what is this part is what? This part, I'm writing this name of the part, it's a mean of cluster, mean of cluster where xi means in our example x3, okay, xi wants to go. Okay, and what is this mu z mu t z I t. Okay, what is this? This is like a your mean of current cluster, current cluster where xi means your, in our case x3 is present. Okay, okay, because its mean, its distance with the future cluster is distance with its neighbor is low. That's why he want to jump to there in the future t plus 1. Okay, that's why he want to jump to the t plus 1. But current, at the current iteration, he just thinking about that, I want to jump to the next one. But what happened now here? What happened now? This is interesting. Okay, this is interesting. What happened now here? So we'll just write the point which he was thinking to go in the future. Okay, in future where he wants to go, he is thinking at the t iteration, but what in the future t plus 1 whole square. In this is a future, he wants to go to that point. Okay, the distance here we mentioned. Okay, but are you sure? Because this guy, he just thinking about this. Okay, is like x3 mu1 mu2. For right now we take only mu1 mu2 here. He is thinking I am now with mu1, his distance is far bigger than mu2. Like he calculated the distance. Okay, okay, so he found that mu2, he calculated the distance a and here b. He said that b is good, b is smaller than a, so in future I will jump. Okay, that's okay, you jump in the future, but as of now time being is mu1 and mu2. Okay, because I showed you the example of the circles earlier, here the point, and they are having mu1 and mu2 for example. Okay, what will happen? Current situation they are having this mean, but once this point will jump here in the next iteration, this circle mu2 will get bigger, correct? Because the mu2 has to accept this point also, correct? So this point, now this point come here and mu1 will shrink, mu1 mu2. This point is for example your x3, and now this point come to x3 comes to mu2 because it's now enlarged, correct? mu2 changed. Okay, mu2 is changed. But once you are just thinking about the future, like the x3 is thinking about future, but what will happen if the x3 is going to is just planning to go to mu3? But what will happen? We are sure that this complete algorithm is converging. It has to jump and go to the one point where he will feel like he is stable. Yeah, ask me the question. Somebody asked the question here, or I cannot see the screen as we'll maybe 10 to 15 minutes, that's all. 10 minutes, I will, yeah, 10 minutes. Okay, 10 to 15 minutes max. Okay, so we'll stop after 10 to 15 minutes. Okay, so he's thinking that this is the point, but as we know that if this is a point, you have to say that because this is where you want to jump. Okay, this is where you want to jump in the future, but once you come to that one, oh sorry, yeah, okay, but what will happen once you go now you are in the, see, your current situation, you are now thinking about future, but now you consider you are now in a t plus 1 iteration. You are now, you have done everything, now you entered into the future, means like you finished your things, you calculated, and you now jump to the next point. Okay, you jump to the cluster here, this situation. Okay, you jump to the next situation, next cluster. So that time, okay, that time what happened? Xi minus mu of what? T plus 1, because now you are in the current situation where you jumped, because x3 was here t, now he is t plus 1 in this diagram. Okay, he was here, but and this what I'm showing in the red color, this is about this diagram. Okay, now xt is saying okay, now I am with a t plus 1. Okay, t plus 1 iteration. So whatever t plus 1 iteration is here, so that iteration, and whatever my this guy, whatever he is thinking, that okay, I am now maybe at the correct iteration, but this x3 is every time thinking about jumping. He is like, he is not happy with where he is. So he is maybe like, he is just thinking like, I want to, should I jump or should I just once again check my distance with the other mean, because now see, these circles got changed, the clusters now changed, the cluster shape, size, everything changed. Now he is just thinking about maybe another there is another mu3 next cluster. So is it like a sufficient distance, or should I also check for x3? So he's thinking like every time to jump and go to convergence, like go and get feel like relax. Okay, so he's just thinking about that, the point. So here in this situation you are now at t plus 1 next iteration. Okay, and this guy zi t plus 1, what it is saying that, the x3 is also thinking about this mu3. So if mu3, if x3 this guy is jumping to mu3, means the current distance, the current whatever the distance you have collected, this has to be minimum, then only it will jump. Because once you fail, it is like current, my this current jump is also not good, then I have to go to the next group, next cluster. So what is that not good means, what you calculated this goodness goodness factor. So this is the goodness factor, like a distance whole square, and you found that this is also not sufficient. I need to go to jump to the next group. So this is what, this is your that equation, the distance of your current, this is your current in the next iteration, you are t plus 1 iteration. Okay, t plus iteration, you calculated this and you found that okay, this is also not good, I need to go to the next one. So it will be either less than, or it also be equal to, means like he can stay in the same current this mu2 group, or he can also think about going into the mu3 group. Okay, so he just thinking like it's like either less or equal to this situation, that's why I put the lesser than equal to. Okay, but what is this? So what is this xi minus mu t plus 1 and zi t plus 1? That is the your iteration, that is the this mu is what, this is your mean value in your next iteration. It's like next, like mu3 iteration, he just want to go to mu3 or not. So this iteration he's just thinking that, should I stay in mu2 or should I just also jump to mu3 new group? So how we can write this one, if I just simply, because we have seen like x1 minus mu1 earlier, correct, x2 minus mu2 whole square plus x3 minus mu1 whole square plus x4 minus mu1 whole square plus, like this we have seen that for the 5 points, correct. This is the example what we have seen, means like mu1 mu2, what this mu1 means what, this is cluster 1, k equal to 1. Okay, is k equal to 2 here, k equal to 1 here, k equal to 1 here, k equal to 2 here, that's why mu2. Okay, so how we can write this this term, how we can write this term here? So if we write here I equal to 1 to n as it is, we can write this is like mu1 mu2 mu1 mu1. So this is the combination here. So I will write something, k equal to 1 to n xi minus mu k t plus 1. Just what I am doing here, I am just saying that indicator function, this is indicator function. Okay, the points which belongs to kth group, kth cluster, that point will only be there equal to k, means if that point is z1 is belongs to k equal to 1, that point only will be there. And this is what we are just, we are breaking this entire, this whatever this entire, we are breaking this entire equation, this complete one summation into this their data points with each cluster. See, this is data points, like here this is one cluster, this is another cluster, this is another cluster, this is another cluster, this is another. So we are just breaking down this complete value into their smaller cluster, like how this looks here, xi minus mu1 here, that's I showed you here. Okay, here. So I'm just doing now summation. So this what is now happening in this one. Okay, so what he's saying, that each point like x1 minus mu1 k, x2 minus mu2, x3 minus mu k. Okay, what is saying that it is just checking each point and its contribution to its mean. Okay, because x1 minus mu1 means what, you are thinking about this x1 point and its mu, you are taking this distance, correct, whole square. You are doing, you are checking that whether I'm just going to stay in the same group or whether I'm contributing for this group or not, or should I contribute to the my neighboring group because this distance is small. So you are thinking about your contribution, like you are, if you are data point, you are checking your contribution to your current mean or current your mean value or average value. What you are doing, you are checking contribution to current mean. Okay, each data point, okay, each data point checking contribution to your current mean. Okay, so okay, this is something you just need to understand why this k means clustering is converging. Okay, so if I just see about here mu k t plus 1 whole square, okay, which is less than or equal to summation of I. Okay, this is cluster ck. Okay, this is belongs to your one cluster, which is xi minus v. V is what your mean whole square. Okay, these are the set of points. This is what, this is nothing but your set of points, like you know that x1, x2, x3, x4 and x5, all these x1, x3 and x5 belongs to cluster 1 and this belongs to cluster 2. So these are the set of points. This what this value, this is like a set of points, okay, belongs to cluster k, cluster k equal to 1, for example. In this case k equal to 1, so they are belongs to, for example, k equal to 1. Whenever there are like a one cluster, so only that point will be here, that points, and only that point, this value we are calculating, x1, x2, x5, these points are here. For only for that point we are calculating their contribution to their mean. Okay, we are just calculating the contribution to their mean. So what it is happening, like we from the earlier fact and all, we now understood that what is this v point. V point is nothing but your mean point, that is what is less than your summation of I, belongs to the same cluster. Okay, I'm telling about the same cluster and I'm thinking about their contribution to that given cluster, which is xi minus mu your current cluster, okay, zi t plus 1. Okay, so you are saying that I am now next iteration, but I'm thinking about my next iteration, and this is the point x3. He is just thinking about should I go to should I be happy with my current cluster or should I go to the next cluster or not. So that's why this is the current iteration, but he is just thinking about the t plus 1. Okay, my next mean, okay, next mean value. Okay, that is nothing but what, okay, xi minus mu t. What is that, that we can say that the k, because it has to check what cluster it has to go. So what it is saying, okay, what it is saying finally, this is what the final things. So what it is saying, that whenever, so this value, whenever, so see, if you don't get the complete expression also, but just understand what the things want. So when it will jump, when these things will jump, when he feels that my current distance of my myself with the current mu is smaller, is the current distance is bigger, and the neighbor has smaller distance, then I will jump to that. I don't want to stay here. So this is what the things. So whenever he wants to jump, he will jump, but making sure that his distance of that same point from its t plus 1, distance of the same point from its next jump, if he jumps to the next point, that time the distance of that point with the next mean is less than the current mean. Okay, the distance of the point with the, this is the current mean, and the distance of the point, because he is jumping here means he is thinking like in future if I just go here, that is like my perfect distance. So the distance of my and with the my neighbor is less than the distance of my current mean. So that's why what it is written. So how many times he will jump, because we know that there are like a two raised to, for example we have two clusters and 10,000 points or 1,000 points, so 2 raised to 1,000 points. So you are just jumping that many times, like 2 raised to 1,000, but it is not infinite, it is finite. Some value will come, some value. It is not impossible, like maybe it will take maybe days or month. If you have a supercomputer, will figure out which is the best solution for best combination, but it is like it is available. Okay, these are finite values, means you have like a finite jump. You are like going from here to here, here to here, here to here, but you are at least you are going to some value, and these are like something which is showing you these are like a finite value. You want to jump to that value, but these are something like a finite value. Okay, finite number of positions. Okay, so that show that this algorithm converges. Okay, means it is saying that I am having x1 x2 x3 these points. I will just go to box 1 or box 2. Okay, but how many times you will go? You will create some combination like x1 x2, or next time x1 x3, or next time x2 x3, or maybe x3 x1 or something, some kind of a combinations it will do. But what, these are like limited, these are not infinite, they are like a limited amount of, and you don't want to repeat it. See, I am just repeating now, this should not happen. Okay, once you are in the same group, next time you should not like create like x3 or x1, this is like wrong. Okay, okay, this combination is already covered, so you should not repeat your combination, you should not repeat your combinations with that one. If you just do the combination and jump into the box 1 or box 2, and you then if you figure out which is the best one, that is what is saying that you are able to converge, because it's not you are jumping infinitely, jumping infinitely. This is like all the finite values only, and at one point you will find out, if you are not repeating this, you are not repeating the pairs, because x3 x1 is same as x1 x3, this is same pair, you should not repeat that. If you are not repeating the pair, then it is okay, it show that you are monotonically reducing the objective function, monotonically reducing your objective function. What is your objective function? Xi minus mu zi whole square, that value should be I1 to n, and dash value should be minimum. So why monotonically they mention? Because if you take some example, it's like 100, then 80, then 60, then 55, 52, then 43, 22, 10, like it's decreasing. It's not happening like 100, 80, 75, 78. It is like, see, it's coming down and it's like once again going up. Oh, it's not monotonic, but this is called as monotonic, means it is actually going to this reduction, it's reducing, it's converging. Okay, it's monotonically reducing, because you are now having finite number of positions that you need to jump from one to next, but at one point, like you need to put this x1 x2 x3, but at one point you should not like repeat your pairs x3 x1 and x1 x3, it's not allowed. You should not repeat the pairs. Once you say that I am not repeating, then you will figure out some at some iteration you will understand that yes, now I am able to, like I am happy with my current whatever clusters I have created, I am happy with that, and hence that say that your algorithm also converges. Okay, so this is just to understand it, like it's converging. So this is what the proof of LLYODS algorithm converges. So it said it gives you this mathematical thing, but if you actually think this is like done, like proof of that, but you every time remember why it is jumping, because its current distance is not is small, current distance is bigger than your future distance, that's why it converges. Okay, and it will converge to the sum, it will converge, it will jump, and it will jump at one point where it's not repeating at all to the next point. It's not like going to x1 to x3 all the box, it's not repeating the same box with same combination, means it's converged. Okay, these are having finite, like 2 raised to 10,000, these are like a finite, these are not infinite. So if I do this much, so then I will also figure out directly also say that yeah, my algorithm converges. So this is how this algorithm converges. So we'll also stop now here. So any questions now, or because we will not take now the next points, is enough for the day. Tomorrow we'll check the other points, remaining points. But yeah, any questions to anyone? Okay, I will close this recording now.